Hi grade 11s, welcome to my channel and let us assist you with some perspective into paper 2 as you are all preparing for the May-June exams. So let's hope this finds you within time. Please practice and perfect the skills demonstrated. Otherwise, you're just going to be simply watching a movie that you may forget the characters tomorrow. But if you practice alongside, especially try some of these questions before you see the comprehensive solutions, then you will have acquired yourself some new skills, some tricks on how to deal with questions of the similar nature, as the paper is not going to be that different, but it may have some challenges within it. And now this helps you to then strategize on how to overcome those challenges. So we're going to take this one from KZN, June 2024, okay? As you can see, I got a copy of STEM of Physics. You can go and have a look there yourselves. Otherwise, let's have a look at the instructions. So please read instructions fully and make sure you understand each one of them. However, I do emphasize these two. Most important about them is that they play a part in how we score full marks in each question in the paper. So it's very important to ensure this. And of course, this part is often missed by many because they take it for granted. This could be anything from a theorem to some law, etc. So this is to suggest that if you've used a particular law that is often necessary to describe or to provide, please do so. Don't think because you're in a particular section you're not supposed to do so. Just do it because the instruction is clear. We need to show everything we have used in determining our solutions. Of course, there are laws that we don't need to justify, we just simply apply because they're self-evident, but others are things that you wouldn't say unless you have a particular structure, and those ones are the most important to state each time one uses them. All right, let's get into the paper and see. So we'll start with question 1, okay? So I'm seated on a chair and table that technically makes some noise. So there may be some screeching sound here every now and then. I hope it doesn't become too destructive. Question 1 reads, in the diagram below, D with coordinates -10 and 6, C it's indicated, E and F not shown, so this means these are potential questions. But we can see F is literally on the x-axis from just looking at the diagram. So any point on the x-axis has some x value and 0 on the y value. But this could be a point of interest since it is mentioned but not given in full. And G with coordinates 1 and 9, again is shown, are vertices of a quadrilateral. So all we see is that they are part of a four-sided figure. Nobody tells us what type of a quadrilateral this is. So our job is to read on. So we are told that F is a point on the x-axis. Of course, that means y is 0 and some x value. The diagonals of the quadrilateral bisect each other at K. So this is now telling us what type of a quadrilateral this is. As you remember, you have not heard of any other quadrilateral where the diagonals bisect each other at a common point, except for a parallelogram. So this is to suggest that our quadrilateral is a parallelogram, because we are told that K bisects these diagonals. And if this is the case, it really says this side must be parallel to that side, and that side must be parallel to this side. And not just parallel, but equal in length. Because that's the indication that that piece, just one line, tells us a lot. So this is what can constitute some tricky questions for less suspecting students. For example, one may be given an equation of this line and just that point and told to find the equation of g. So how would you do it? You would take the gradient and then use this point and get the equation. But essentially, that is just how sweet some information that is not given so clearly means when you interpret it. Now the equation of diagonal EG is, so of course the way it's written I don't like, so I would prefer to write it the standard way. It's going to be 3x plus 6. So basically we just simply transpose y into the side. Now we can use it nicely because we know that it uncovers the gradient is 3, okay, which can help us to find that angle of inclination. Alright, and beta is the angle of inclination of EG. So this is good because we will see now that we can use that gradient of 3 to essentially get that angle beta. Right, so what can we do with the piece of information that we have? Well, at this stage, we only have the equation of this diagonal. And what we can do about it is to literally uncover that angle beta. Okay, that's all so far. We don't have enough information to get the coordinates of E, nor we do have enough, in fact, we don't have enough information also to work out the x-coordinate at F. Remember, these are the 2 points of interest. And we have nothing on the gradients of this line right here. So this would make this one also very challenging at this point. But we've got 2 points on DG. So this means we can find the gradient of that line, which will effectively be equal to the gradient of EF. We can find the equation of this line and perhaps read off its y-intercept. At this stage, that's about what we have. We don't have much more than that. So this is to suggest we will need more information before we can work out the coordinates of K, because K is also a point of interest. But we don't know what to do. E is a point of interest. We don't know what to do as yet. So essentially this says some extra information needs to come down as we work through the questions. So a student who really wants to pass, you want to look at the questions and see what you can do so that you can choose the questions that you can handle first and move on. So calculate the size of beta. We can see we have a strategy for that. Calculate the coordinates of F if the equation of DF. Can you see now? Extra information. Where is DF? DF is this diagonal, is as given. And now we can see clearly that this will help us to find the coordinates of F. Because from a full equation, we will then be able to find the coordinates of F. And in fact, that's the question, because it's the x-intercept. So now we have enough information. Calculate the coordinates of E. Well, 4 marks, and we can see once we have the coordinates of F using the midpoint expression, we will then first find the midpoint of DF, then from there use GE to work out the coordinates of E. So 2 steps in a way. Prove that DEFG is a rhombus. Can you see? First, it is a parallelogram, but now specifically we need to uncover that this is a rhombus. And what do we know about a rhombus? All sides are equal. We already know this is a parallelogram. That's a part and parcel of this. But specifically, we need to prove that this side DG is equal to GF equal to EF equal to DG. That's another way we can do it. Or we can just prove that in a rhombus, we know the diagonals meet at right angles. So we can just simply prove that this is perpendicular to the other diagonal. So we can prove that the diagonals are perpendicular. Looking at 3 marks, you can clearly see that, okay, all we need here is probably this, because we will have the gradient of this line given already, and the gradient of the other line is coming up from here. So we can work it out by multiplying the two. And of course, if you write this equation in standard form, we know that y is going to be equal to, now we transpose x is going to be minus a third of x plus 8 over 3. So this is how it's going to look. And guess what? See, this is 3, this is minus a third. This product gives us minus 1, which proves that indeed these two are perpendicular to each other. So this is how we score the last 3 marks. So essentially, studying the diagram, knowing what you can do with it before looking at the questions, you will see some areas that probably uncover some uncertainties. Then skim and scan through the questions just to see if your strategy for each is clear, so that those that are not clear, you don't want to waste your time with those immediately unless something clicks as you look at them. This is to save time, at the same time scoring as many marks as you can. Alright, so let's start with 1.1. So we are told to find the size of beta. So we'll start by saying, well, we know that EG as a vector is given such that y is equal to 3x plus 6. This is given. So there's no need to justify anything here. We can say then tan beta is going to be equal to the gradient of EG. Right? This implies that tan beta is basically equal to 3. This also implies that beta is going to be the arctan of 3. Therefore, beta is what we are going to get. Unfortunately, here there's no guessing this number. It's not a perfect square kind of a thing. We'll just go shift tan 3 and we get 71. Comma. Now we're going to be specifically answering to 2 decimal places because there's no specification in this particular question. So we stick with the general instructions. So how do we score marks here? Of course, guys, writing this portion here where you can easily see this as substitution and perhaps that as the answer. So the 3rd mark, it's a bit not so clear, but perhaps one can think of this point or even rearranging that equation. So this depends on the examiner's discretion, but for us, we need to just do the proper calculation and step away. Now we're told to calculate the coordinates of f if the equation of df is as given. So what do we know? Well, we know that df, first of all, as a vector is such that x plus 3y, at this point, this one you don't need to manipulate as yet, is like that. We know that here for x-intercept, it is such that x plus 3 into 0 is equal to 8. Okay, so therefore x is equal to 8. Right. So this is rather aggressive, eh? Because look, this is 1 and this is now 8. Am I missing something? Not at all. Not at all. So this is what we have. We can say therefore f is 8 and 0. Because if we've got the equation of df, we literally are going to do exactly that. But again, even though it looks outrageous, but look at this point right here. This is like 1 here, this is 0, but do you see not so far, more or less an appreciable distance like this, we're already at 10 units. Slightly longer, of course, than this, but not too long. So we know that, okay, it's not too outrageous according to the diagram. Although it's not drawn to scale, but we can comfort ourselves with what we have. So guys, here what matters is to recognize this is an x-intercept, substituting 0 and working out the 8. But we get full marks if we present our answer in the ordered pair, because this was clear that we need to find the coordinates, not an x coordinate perhaps. All right, so try to answer strictly according to the instruction, which is the question itself. Now we are to calculate the coordinates of E. This is good because we were told K is the midpoint of each one of the two diagonals. So we're going to use that to our own advantage, so to speak, except my notations here are not quite good, so we can't have similar notations, you know. If I've got 2 lines there, I cannot use 2 lines also. So again, I cannot use 1 line either. So we need to be careful of how we annotate our diagram. So we try to not use the same symbols, because we're not trying to say all of these are equal. Because if we start doing that, we'll start giving the impression that those things are equal. Of course, what can we say, guys? We will say K first is such that x at D plus x at F over 2 is to y at D plus y at F over 2, right? This implies that K, I don't know how to write K properly. Perhaps I'm too much in a hurry. X at D is minus 10 plus 8 divided by 2 is to 6 plus 0 divided by 2. Therefore, K is going to be, this is 10 minus 10 plus 8, that's minus 2. Minus 2 divided by 2, that's minus 1. Okay? And this is 6 divided by 2, which is 3. Does it make sense? Yes, K is a point in the second quadrant. X is negative, Y is positive. And it should be less than that point over there. So both the X and Y values make sense. So we can accept them. We will then say E is of this category as well. X at E plus X at G over 2 should give us X at K. Likewise, Y at E plus Y at G. So everything looks more like the same thing now, hey? Over 2 should give us the Y value at K. We were told the diagonals bisect each other, so we don't need to justify this. So this implies that E is X at E. Now, plus X at G is plus 1 over 2 is equal to minus 1. And Y at E is our interest, plus Y at G, which is going to be plus 9 over 2, should give us the Y value at E, which is, at K, which is 3. Now from here we can make a conclusion that we cross multiply. So the gymnastics here is cross multiplying the denominator across. Of course, this is over 1, so it multiplies that into itself. We will then be forced to transpose the constants into the other side of the equation. So we say this is minus 2, minus 1, so this becomes minus 3 is 2. This is essentially 6 subtract 3, sorry, subtract 9, we get minus 3. So it looks nice because if we look here, this is a point in the third quadrant. So both x and y should be negative. And seeing that this point was -1, this is just off -1. So it makes sense for a -3, okay? And since this is not that far also from the x-axis, 3 looks reasonable. We can take it. So we can safely say, okay, we accept this answer. Excuse me. Although we may have committed some crimes in terms of the numbers, but the answer is not too outrageous, I guess. So how do we score these marks? Obviously, folks, one may say substitutions here and getting that point. Remember, it was not asked for directly, but the one that is asked for is this one. So usually for those two coordinates, because this formula is more or less the same as that. So in essence, you would not be marking some substitutions the second time around. But we need to see the flow of things now. We can't just end up with these coordinates and we don't see where they came from. Remember, a question that says calculate, we cannot just jump into conclusions. We need to show calculations. So please be particular about the instructions in a question. Do not lose sight of things. In fact, I can squeeze in 1.4 here. Now 1.4 says we need to prove that this is a rhombus. First of all, we know this is a parallelogram. That is good. But now we need to argue the part of being a rhombus, and that means we need to prove that the diagonals are literally perpendicular to each other. Great. So we will say, first of all, we know that D, E, F, G is a parallelogram. Why? The diagonals bisect each other. Diagonals bisect each other. And that was given information. We will then say, we can check now that, well, the gradient of DF multiplied by the gradient of EG, what is it equal to? The gradient of DF is literally -1/3. Okay, as we could see, we don't need to show how we got that. The equation was given. Then we multiply this by the gradient of EG, which was also given to us, which is a 3. So this gives us -1. We can say, therefore, DF is perpendicular to EG. Please don't use parallelity. I sometimes make that mistake carelessly. So if this is the case, it therefore proves that DEFG is a rhombus. Nice. Why? Because diagonals of D, okay, let's just say diagonals are perpendicular to each other. All right, so can you see we've provided reasons, because we don't just do calculations that nobody understands. There has to be clarity. First, we needed to prove this is a parallelogram. That is a powerful statement. Proving that these diagonals, essentially their gradients, end up at -1 is good. And of course, the final statement with the reason is what makes up those 3 marks. And in essence, we take those 12 easy marks of this question. So folks, be very, very careful on how you handle business in your questions, in your exams. Make sure you don't leave any ambiguity in your answers. Dispel any misconceptions by being very clear and particular. Doesn't matter what your teachers say at times, because most of you write these papers, they become literally provincial papers or district papers. So sometimes the person who is doing this, or perhaps who created the exam, is not a person who teaches you. So this is why you need to be very, very, very careful, because the very teachers who teach you, they have a tendency of victimizing you according to the memorandum by someone who did not teach you, because I don't understand that part. You know, I have been listening to some memo discussions of different provinces at some point. I was happy with one province. You know, the Free State, they tend to defend the way their students have been taught in their particular school and how they projected their answers to try and create this comprehensive memorandum that essentially encompasses all techniques that are in use and in fact are acceptable. But I seem to see that in our province, EC especially, they do not seem to drive the message of their students better than they would drive a message by someone who does not even teach those kids, which for me is a bit of a problem, because yes, maths is always going to be maths, right? It's more or less a universal language, but there are still variations in how we teach it in different countries, even in a country, in different provinces, even within the provinces, in different districts. So there is a lot. We can even go into the same district and say in different schools. Can you see? There's so much variety in how things are executed. And of course, this is influenced by the available staff members that we have and their quality as well. So it's very, 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 very delicate a matter that I feel is not handled properly. I feel we should do more. Of course, I'm saying that as a we, but I know I'm an insignificant part of the equation. I'm not even a coefficient. So, yeah, whatever. Let's move on to the next question. So guys, be as quick as you can. Once you know what to do, trust me, the questions I just did, you can see that I answered them in less than 20 minutes, technically, the answering part. As you can see, some time got taken off by just analyzing, which is not a bad thing. But of course, you guys jump in and just do your thing. It's okay. But I'm just trying to make sure that you see better and you do better, because at matric level, you're going to get stuck if you just jump in. Okay, in the diagram below, A with coordinates -2 and -1. So there is A. B with -3 and 4. Again, we can see it. C, 1 and 5 are vertices of a triangle. And we can see the triangle is ABC. BC is produced. Now that statement, guys, needs to be understood. When we say a line is produced, it's more like an extension of that line. So that means there's no angulation at the ends of that line and with the continuation. So if BC is produced, it means CB or BCD is a straight line. Okay, so the interpretation that we can say is that BCD is a straight line. Very important to appreciate that. To D, and we've got an ordered pair that is not fully given. So we've got 5 and Y, meaning Y is a potential question. We need to find it. We need to think about how we're going to find it. AC cuts the y-axis at F. Okay, so this is an x-intercept. So an x-intercept, sorry, a y-intercept has 0 as the x-coordinate. So the most important thing is saying, please find the y-coordinate there. E is a point on the x-axis. Of course, here we know that y is going to be 0. But now what is the value of E? On the x-axis such that CE is perpendicular to the x-axis. So this portion is suggesting that this is a horizontal line. And any line, sorry, vertical line. Any line that is a vertical line on the Cartesian plane, it simply means that line is parallel to the y-axis. Right. And if that's the case, it means the x-coordinated C is the same as the x-coordinated E. So this means it's 1. So someone is giving us the coordinates of E indirectly. Of course, it may be a question. If it is, we will look at the quality. If it just says write down, we just do so and we don't justify. But if something says determine, we may have to put in some justification. But remember, a determination can also be done by inspection. So where we don't provide perhaps some reasons why we did what we did. So you look at the marks as well. For 2 marks, you don't need to do a lot. But for more than that, you cannot just say less, okay? If you have to say something. So can you see we're interpreting this thing as we go along? We're not just reading and then we just jump in. Now at this point, we can see that, well, what seems to be of interest is that point D. How will we find point D? Well, we just simply find the equation of BC, because if this is a straight line, it means the equation is a vector for the entire line. So we've got 2 points on BC, so we can work out the gradient and the equation. And within that equation, we can substitute 5 and get the corresponding y value. So at least we can handle things here. What about F? Well, we can see that we've got 2 points on AC. We can get the gradient. From the gradient, we can work out the equation. And in the equation, we just read off the y value. It's going to be the constant in that equation if we write it in standard form. 2, we can get its angle of inclination. Good. We can also get an equation of this line BC by finding its gradient and using one of the points to find the equation. Then we can get an angle of inclination of that line. On top of that, we can even work out the x-intercept. So it helps to always be aware of what you can do. Do you have enough information on the diagram to do all those things? Because trust me, the questions the questions are always going to be around those obvious areas. Perhaps some extra ones at times, but it doesn't really matter. So when a question is this nice, you know what to do about all of the parameters on the diagram. There's no need to skim and scan here, because you know that most of the questions are going to be around those areas and you already have a strategy. So you're not interested. You will see if there's any issues or new information, then you deal with it as you go along. Now the first question says calculate the length of AC. Easy. 2.1 AC is going to be equal to the square root of x at C minus x at A all squared plus y at C minus y at A all squared. I find this method very important and particular because if you start writing x1 minus x2 or x2 minus x1, you're just being generic. And remember, the generic equation is just a template for you. Now you will end up needing to reassign values again to these equations. Remember, these are already named E, C. Now you are renaming them, like you're giving yourself an extra amount of job. And if you mix those numbers, you end up lost. But if you just use what you have, you'll just have this, and you look at the sketch, you will see that x at C is perhaps 1. And then x at A, you can see it's minus 2. Can you see? You don't need to keep naming things after they have already been named. But again, however you see this, it's up to you. But what we provide, guys, is precision. Remember, maths is precise. It's not as crazy as many people make it to look. So x at C is 1 minus x at A is going to be minus what is this? Minus 2, which is going to be plus 2 all squared into y at C. This is 5 minus 1 is going to be plus 1 all squared. At this point, there's no need to simplify here. We just give an answer. Of course, we said simplified set form. See, the manner in which the answer should come is also very good to think about. So this is 4. 4 squared is 3. 3 squared is 9. This is 6. 6 squared is 36. So this is going to be 36 plus 9, which gives us 45. Now 45, is there a perfect square that goes to 45? Let's see, but you can just use your calculator. I don't think there is. Wow, there is. 45. Oh my lord, it's 9 times 5. So 9 times 5, we know 9 is a perfect square, so the square root of 9 is 3, so it's going to be 3 root 5. But anyway, you've got the calculators, guys. You don't need to crack your skulls. You don't need to crack your skulls, but don't deny your brain growth. You need to engage it so that it doesn't get tired or it ends up, you know, preoccupied with other things. You start thinking about playing soccer or other things within an exam, and you end up losing your logic. So keep it engaged, but verify every action that you take. Of course, guys, substitutions into a structured formula and the answer in the required manner is how we score the marks. 2.2. We need to find the gradient of BC. Nice and easy. So we know that the gradient of BC is going to be y at C minus y at B divided by x at C minus x at B. Again, I find it very useful to use the very points that you're already given rather than to rename this y1 minus y that. But if that is the way you want to do, there's nothing wrong with it, but just make sure it doesn't end you in a curve out of commission, because you are going to fall. And mind you, this is your future we're talking about. So you need to ensure that you secure your future at all costs, or else you're going to wish you had put more effort in ensuring that you understand your things. Okay, so this is how it's going to be. So 5 minus 4, that's 1 over 4. So it's a quarter. Okay, it's very gentle. It's a very gentle gradient. So this is good for it to be a quarter. But a mistake may have happened, obviously, but I don't see it at this stage. So this looks good. Again, 2 marks, substitutions, and the answer into a structured formula. If this is missing, you are not adhering to the general instructions, so you may lose a mark because we don't know what you are substituting into. Yes, the examiners know maths, as well as the people who are going to mark, they know maths, but that's not them in the test, it's you in the test. So in the test, we are testing you, not them. So don't provide a test for your markers, because you're going to lose marks. Because easy questions, as I said, there are very tight restrictions on those, because this is what you should know better. So your performance has to be at your very best. But difficult questions, higher grade questions, we know that we're checking if you can go to the limits. So there we can allow a bit of erratics, or should we say erratic, approaches, shaky approaches. We can accept as long as they show us you are actually using your brain in the process and you're figuring out things using your knowledge. But easy questions like this, there's no forgiveness if you don't adhere to strict instructions. Because what would be your excuse here? A lot of you get surprised by this and they okay, calculate the value of y if b and c are collinear. Can you see they are just being too friendly, because they already told us that this is a produced line. So those are collinear points, literally. So it was already, if we say BC is a straight line, this already meant A, B, and D are collinear. So those are the points on the same straight line. So essentially, this one, I feel like it's made into a lower grade question, and I don't understand, because, come on guys, we're not going to be rewarding distinctions to students who are just being given lower grade material. At least keep it standard then, if you don't want higher grade, but not lower grade for sure. This is a lower grade question, and I am concerned. We can't have that. We can't give 3 marks for a lower grade question like that. Standard was good enough, because the production is already suggesting it. So it's upon the student to know what to do. But what are we looking for again? We want the y value there. Of course, we know the actions are going to be a lot tougher, because we just need to know the fact that the gradient between any 2 of those 3 is the same. That's the message being given. So this is to say what we found above, we can use below. So we know that, okay, the gradient of CD is the same as the gradient of BC. Why? Because A, there's no A. It's because B, C, and D are collinear. This would have been something you should say instead of being pushed into. But again, it's okay. Examiners know that probably there are some stones along the way, and so they just want you to sail through here. So this is going to be, in fact, why am I suffering? So we can just say y at D minus y at C over x at D minus x at C should be a quarter. Right. This also implies that we have y minus 5 over 5 minus 1 is equal to a quarter. Now be patient with the steps, don't be in a hurry. Y minus 5 over 4 is equal to, so this is going to be a quarter. Now we just cross multiply the 4 and we transpose. Of course, you're not going to show those lines, but that's literally what you're doing. So we can say therefore y, remember this is going to be 4 divided by 4, which is 1. We add 5, it becomes 6. So this is done. Nice and easy. So we just used the gradient this time because these are collinear points. Again, we didn't need to actually find the equation, but you could have gone that way. Because remember, at the same time, the way you see the question is the way you're going to approach it. Simple as that. But some extras perhaps suggest something you never thought about. But in essence, you should know about anyway. So the 3 marks, I suppose, is going to be stating this, right? Then we can say the substitutions and the final answer. Okay, so it's a normal 3-step, not 3-step, just a single-step calculation. In a single-step calculation, you have a formula of some sort, substitutions, and answer, right? So this is the standard question, but they made it lower grade now, which is lower than the standard, and I'm not happy. Okay, and still maintained the marks. No, 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 no. Remember, guys, we still have to examine these guys. We can't give them nestum and purity. No, no, no. They need to bite on bones and chew on some hard roots and stuff so that they can become tough and strong. Okay, if H is a point such that AH is perpendicular to BC. All right, determine the equation of AH. Interesting. So obviously this is a higher grade question now because it needs you to show us your critical thought and your problem solving skills. Can you place this on the Cartesian plane properly and essentially give us what we are looking for? Now obviously, guys, a student who's careless would want to place AH perhaps here. Well, it's okay to do so, but do you realize that even the sketch defeats that purpose? Oh, this thing jumps. Come on, man, stop jumping. That doesn't look perpendicular. It's obtuse. It's over 90 degrees. So for me, it would make sense to try and extend this line. Okay, I'm just going to do this. No. Goodness. Giving me headaches. Okay, what I'm going to do, I'm just going to extend this over there. And then try to see that the line that I'm going to draw is perpendicular to this and goes to that point. Still doesn't look exactly perpendicular, but it's a bit better than the other one that I would have drawn. So maybe let's try again. Okay, that looks a bit better. So we can see that this is the perpendicular story being given. And of course, this is to suggest that if we were to look at this triangle ABC and BC as a base, the height is going to be outside because it's a scaling triangle, so to speak. And then of course, guys, when you do a produced stuff that you were not told to do so, you just showcase this as a dashed line. And we can do that and say, well, that is point H. It's so close to point B. Okay, so if you wanted the point of intersection, you can prove that, because if we're using this condition, it will prove that our positioning is good. But again, be very careful when you're looking at the sketch. You must be able to see that. I'll prove it to you just shortly. But now let's first deal with this problem. So we can clearly see that, well, the gradient of BC is related to the gradient of AH. So we can just say gradient of AH times the gradient of BC. We should get -1. Why? It is given that AH is perpendicular to BC. Again, you don't need to state this one because given information is already understood. But what we're interested in is the gradient of AH multiplied by that of BC. We already have it as a quarter. And you can see this is a very steep negative gradient, so it should be -4, isn't it? Yeah. Literally, sorry, not 1, but -1, okay? Therefore, the gradient of AH is going to be -4, right? Because that's what's going to happen. And it makes sense. It's a very steep negative gradient. Now we need to find the equation. We'll say then, we know that AH as a vector is y equal to -4x plus c. Now we use a point A, which is -2 is to -1. It's going to be such that -1 equals -4 to -2 plus c. Therefore, our c, this is going to be 8 transpose. It's going to be -8, so it gives us -9. Okay, that's not too bad. If this is -1 already, so -9 makes sense. It's going to be a bit far down. So therefore, we know that y is -4x -9. Nice and easy. So the key was to know this relationship and find the gradient. So the gradient is key here. The substitution of a point is key. And the equation as required. Of course, standard format is usually what is implied, if nothing else is stated. But if someone wants it in a different format, they will state that format. If not given a specific format, we follow the standard format. To avoid trouble. But if you can present it in another way, it's okay. But be very sure that that way is going to be correct. Or you will find yourself victimized for being too clever. Okay, so 2.5. We need to calculate the coordinates of G if cabbage, oh my God, coronary bypass arterial graft, my goodness, talking cardiothoracic surgery. Okay, cabbage. Now let's see. CB, what? Calculate the coordinates of G if CBAG, okay, CBA. Therefore it means, remember, a parallelogram is such that this point C is directly linked to A with no other zigzagging, and B must connect to A, and A must connect to G like that. It's a continuity. So we know that if this is CBA, it means G must be on this side for this to be a parallelogram. So, well, what I'm going to do, because I know I have gymnastics up my sleeve, so I'm going to do this. Right, and then crop this and move our eye when I'm crop this, move along, so I know that C must connect to G somewhere. Okay, so that is the story. This one is flying. Okay, now that looks better. And of course I can take this and move along with it. But what happened now? Why is it short? Is not good, eh? Is not good. Anyway, I will take that which I just did and perhaps remove this one because it's not representative. So it's messing up my game. It means this is not really something that was thought. It is just something that is imagined. So, well, I don't like questions of this nature because, you see, it doesn't look like a parallelogram now, does it? Not at all. Not at all. It looks terrible. It looks terrible. Okay, I guess we go back there. That makes it look a bit better. Although we know that it's not a palm, unless I didn't do it well or I didn't do justice to it. Of course, guys, try to ensure that you can separate these lines from the ones that were given, because you still need to see that sketch and work with it. So with a palm, we know that this line must be parallel to that, okay? And that line must be parallel to that. That's about it. Okay, so we need the coordinates of G. So this must be G right here with X and Y. And guess what? The property we just used above, we know we need this dude. All right, our coordinates are becoming messed up here, so I still want them. Okay, so we know that basically the diagonals of a parallelogram bisect each other at a common point. So we can say, well, we have got B, C, D, and E, F, and then we can call this point G. So we already have AC. So if we find the midpoint of AC, we can use that to find this. Easy stuff. Easy stuff, easy stuff. Or we can look at symmetry. If we see this point, we know that we have moved this point. Okay, but we still need this, right? I feel so. Or we can technically say we took this point down here. So this was a horizontal distance of 1. So we added 1 there to get -2. And then we subtracted 5 to get -1, right? So can we do the same here? We add 1, it's going to be 2. Just going to check. And we need to take this one down 5. And now if we take that point down 5 units, it lands us in the x-axis, so to speak, because this becomes 0. And now this is not quite, but it looks okay. But let's see. This looks different. This is why sometimes I don't like sketches that are just randomly thought of, because you will see that if you try to fashion a parallelogram there, you see it gives us the wrong impression that this is the point in the 4th quadrant. That's why I hate structures that are not thought of beforehand. You see, this guesswork when creating questions is not very fair, because it defeats the purpose of the question being of a higher order nature, but it clearly just creates confusion. But anyway, to avoid this issue of symmetry, let's just work through it the way we did above. So we will say let G be the midpoint of AC, such that, okay, remember when you name something, it's because you don't want to end up with a G you never spoke about. This is to suggest that G is going to be essentially x at A plus x at C over 2 is to y at A plus y at C over 2. This implies that G is x at A, it's minus 2 plus 1 divided by 2 is to minus 1 plus 5 over 2. Okay, so we can make a conclusion that G, this is going to be minus 1 over 2, so it's minus a half, is to this is minus 4, sorry, it's 4 divided by 2, which is 2. Okay, not too bad. It looks like it there, because we found, or we didn't find the coordinates of F, and in fact there's nothing here as yet about that, so we cannot worry about it at the moment. So we will say then, we understand that G, goodness, G is what we want. Holy cross, we can't let this be G. Let's let this be H instead. Okay, I'm making a mistake, so we cannot name something that's already been named. So this means we need to be saying H instead. Alright, so we say then G is going to be x at G plus x at B over 2 should be equal to x at H, the midpoint. Therefore, y at G plus y at B over 2 must give us y at H. Of course, if this is a whatever parallelogram, but now we need to justify this one at this stage. We cannot just say, we know that diagonals of a parallelogram bisect each other. Can you see? We cannot just say this without substantiating for that. We need to be clear. Alright, so this implies that G is going to be x at G plus, minus 3 divided by 2 is going to give us minus a half, is to y at G plus 4 over 2 must give us 2. Alright, so let's see. Therefore, G is going to be gymnastics. We cross multiply, we get minus 1. We add 3 there, we get 2. Can you see that one came out? Then we cross multiply 2 there, we get 4. We subtract 4, we get 0. So it means symmetry worked. So this is indeed correct. Wow. But it then proves that this parallelogram was not thought of properly. Because remember, I used that gradient, so it means it should be going like that, and it doesn't look like a parallelogram when we do so. But you could see it didn't match up nicely, to just show that no one did the parallelogram first, found the coordinates of G first, so that they match what it's going to look like. So these are the questions I hate, honestly, because whoever is the quality assurer here is failing to do their job. Because folks, we need to not mislead. I know this is a sketch, but you see, this will not make sense to a student who really uses the sensibility in all of this than just going through the motions. As you can see, symmetry could also help us, and it gave us those. It's just that I doubted them looking at when I construct or finish a parallelogram using this sketch. But of course, they are justified by the part that says the sketches are not necessarily drawn to scale, but I worry when the structure that comes up is not representative, because irrespective of being drawn to scale or not, we should not have a situation like this, where G doesn't appear to be where it should be. Because honestly speaking, these are specific figures. So we cannot name a figure that doesn't look like it as such. Okay, because it's very confusing. So you would be shaky about, are these coordinates correct? Well, they are. Because we did two techniques and two techniques yield the same answer, then it means we are good. So what is the story now? We're just getting 3 marks. So what is the question? Is on the coordinates of G. So I guess we need that and that 1 mark, it seems. All right. We leave it at that. So 2.6. We now have to find the area of CEOF. Okay, where is it? All right, so we see there is our CEOF, and we already uncovered the coordinates of E nicely using that property right there. Now our only challenge is F. We thought about F. Yes, we didn't get a chance to work it out, but now we have to. Okay, we have to. But again, we can use the fact that this is a gradient, because we did calculate the gradient. Oh no, we did not. We only calculated the length of AC. We didn't do the gradient of AC, but we can actually use the gradient rather than the equation, because to find the equation and then rid of the y-intercept is going to be a bit hot. But at the same time, sorry, if you think about it, you would understand that we can still find the equation anyway, so it's not a big deal. So it's a 4-mark question, and what we can see, this is a trapezium. So the area of a trapezium is nothing but the sum. It's half the sum of the parallel sides, right, times the perpendicular height between them. So if we found the coordinates of E, which we need to state by the way, then we know that we already have the height. Then we just need to find the coordinates of F. We would know that part because this one is easy. Nice. Okay guys, so let's start our job. We will say first of all, E is the point 1 is to 0. Here we're doing this by inspection. We don't care. We're not going to explain. But we can, if we want, can say basically CE is a vertical line. Such that x at E is the same as x at C. See, it's nice when you say things to suggest that you know them. You're not just saying it out of guessing or somebody has whispered this or you copied. Because this becomes you. And no one can doubt that this is your performance unaided. So try to be like that, folks. All right. What else do we say now? We will say also. So this is also, again, a higher grade question because you've got to find your way around. So we also know that basically we also know that F is such that 0 is to Y, okay? And how do we know this? Is the y-intercept of AC, such that what is going on? We know that basically y at F minus y at c, for example, should be divided by x at f minus x at c, must give us literally y at c minus y at a over x at c minus x at a. How do we know this? It's because we know that a, f, and c are collinear points. All right, because they make up a diagonal of that parallelogram. That's another statement that is trying to give us that AC is a straight line. So any point on that line is what we see. So this question is a bit naughty, honestly. So y at f is basically just y minus y at c is 5 divided by x at f is 0 minus that at c is 1 is equal to y at c is 5 minus 1 is plus 1 divided by 1 minus 2 is going to be plus 2. So can you see it nicely solves our pain? So y at minus 5 divided by minus 1 is equal to, this is going to be 6 divided by 3, which is going to be 2. So we just cross multiply, we get minus 2, we then add 5, we get plus 3. So therefore y is 3. Because what are we going to do? Gymnastics, we cross multiply and then transpose. Of course, you don't show these, the two gymnastics I just showed, you just need to know this. Now once we have the full coordinates of E, you can say therefore E is nothing but, not EF, sorry. So F is going to be 0 and 3. It makes a bit of sense, isn't it? Yeah. So we can say then area of CEOF is going to be half, basically OE, not OE but OF plus EC if we want, half sum the parallel sides times the perpendicular height, which is going to be OE. Try to write it in terms of the structure that we have. So this is a half. OF is going to be just 1 unit plus EC, we can show that, but again it's just 5 units up, isn't it? So there's no need to calculate there. And don't lie, OF is not 1, OF is 3, sorry guys. And then OE is 1, so which gives us, now this is 8 times 1, which is 8, divided by 2, that's 4. So this is 4 square units. Okay. Nice and easy. So can you see, guys? Strategy will always work. Of course, I'm trying to take time to get you into the groove. Otherwise, it's easy to sail through these questions if you've had adequate practice. As you can see though, 2.6 is one of those higher order questions where you have to demonstrate, your critical thinking there, problem solving skills, and execution in style. Of course, finding the coordinates of E is a very key step in this problem solving. Secondly, finding the coordinates of F, but I think here it's not really a strategy that we need to worry about. But I suppose this, how many marks? 4? I'm a bit unhappy though, because we've been calculating gradients. Maybe this is key, because the substitutions are very key, and the answer, wow. That should be 5 marks though, because I feel this is a critical step in this problem as well. But again, you can just check the marking guidelines for a clear guidance on how the examiners structured the mark allocation and exactly what strategy or approach was used. But at the same time, it doesn't make your approach less important, because that's how you saw the problem and that's how you solve it, as long as the problem is taken down at the end. Key is to take down the problem, not to leave the problem hanging. Now let's get to trigonometry. So you guys are going to do analytical geometry. As you can see, the first question is going to be some standard grade questions. As you saw, there wasn't much except for the last one. You wouldn't think about it. It's more of a higher grade question. The rest are standard grade questions, honestly speaking. Then here you can see there was a series of higher grade questions. Those three I would qualify as higher grade questions. But then they put in a lower grade question and I'm like, why? Okay, let's get to question 3 without wasting time. Well, we are told a story here that cos 23 degrees is equal to the square root of 1 minus g squared. Of course, we always write this as a ratio because these are trig ratios, and so that we can be able to do our diagram on the Cartesian plane, because we know that this type of questions, the terminal arm related questions, are always going to be solved without using a calculator in the majority. Although we can strategically use our calculator, but generally not accepted. So 23, it's an acute angle, so we know our terminal arm is in the first quadrant. Drop it down to the x-axis and show that it's perpendicular. And of course, this is a construction of ours, so we know that it was not necessarily there, but this is 23. Now, always calculate all the angles in these kinds of questions. So if that is 23, remember it's a complement of that angle when this one is 90. So we can easily say 90 minus 23, which gives us 67. So you don't need a second invitation. Trust me, with the terminal arm diagrams, always when you draw a triangle, get all the angles. There's usually enough information to do so. And after this, we know cos is defined as adjacent over hypotenuse. So the numerator is the adjacent. So this is going to be 1 minus g squared over 1. So if this radius is 1, we know this is a standard circle. We call it that. Now we need to solve for y immediately. X squared plus y squared equals r squared. We know this from Pythagoras. So x is the square root of 1 minus g squared all squared plus y squared equals 1 squared. This implies that y squared is equal to 1 minus, when we square this thing, the whole thing is going to come up like this. But be very careful of how this is done. And what is the story? We get y squared equals, the ones cancel, it's going to be g squared. Therefore y is basically g. We're choosing the positive version. Why? Because this is the first quadrant. The y value is positive. So we determined. So with these kinds of questions, we always work out all the sides and all the angles. That's the strategy. And you don't need to be invited to do so. From just the information given, this is what is important. Okay, so it says express each of the following in terms of g. Nice. So we start answering. So we have 3.1. We need to find sine 23. Can you see? Sine 23 degrees is opposite over hypotenuse. So it's going to be g over 1. Please write it as a ratio first. and make a conclusion. Therefore, sine 23 is nothing but just g. But now how do we score the marks? Remember, working out this g is part of the problem solving. Defining sine is good. And of course, we need to at least try to showcase it in terms of g. But if you think about it, it's one and the same thing. So I wouldn't think this is more than just 1 mark, perhaps 1 mark. But I think most of the gymnastics happened here. We can say, well, writing this into some Pythagorean theorem here and doing all the gymnastics leading up to the answer, I think it's worth a mark than the final answer here. But we still need to follow the standard approach. Okay, so 3.2, we need to deal with tan 113. Now tan 113, remember we always reduce this to an acute angle, so this is going to be 180 degrees minus, in fact, it becomes a bit chicanery. 113 is too little, so it's going to be 180 minus what? 23? Definitely not, but 113 is 90 plus 23, right? So this one goes with cofunctions. I don't know, guys, if you still do cofunctions in terms of sec and cot, because the cofunction of 10 is cot, right? Yeah, it's cot. As well as it is a reciprocal, it tends to be a cofunction. So guys, this one is crazy. So let's see, 10, 1, don't go. Don't go there. So this is equal to 10 of 90 degrees plus 23 degrees. I don't know what you know, guys. The cofunctions in grade 11, are they different from the ones in grade 12? I'm not too sure. But hey, let's look at the marks. It's just 2 marks. So I would suppose, wow, this is crazy, guys. I would show you this one. Don't gale question can't go. Don't gale question can't. Anyway, I'm not quite pleased. I'm not quite pleased because this should be equal to cot 23 degrees. And cot 23, sorry, minus cot 23. This is going to be, cot is the reciprocal. Now remember 10 is adjacent, sorry, opposite over adjacent. Cot is going to be adjacent over opposite. So this is going to be the square root of 1 minus g squared all divided by g. Of course, I'm not too sure if you guys use cofunctions like this in grade 11. Because in grade 10, I know cot and sec, cosec are still acceptable. So I'm not too sure about this question. But let's try and do it perhaps the way that you would be expected to do it. This is sine of 90 degrees plus 23 degrees. Using identities divided by cos of 90 degrees plus 23 degrees. Of course, for 2 marks, I doubt this is the way, but I don't know what your curriculum says. So sine plus is going to be basically cos of 23 degrees divided by, this becomes minus sine. In fact, this should have been negative there. It's going to be minus sine 23 degrees using cofunctions. And what did we say? Cos of 23 was that. So it's still the same answer. But now it's going to drag a negative. Going to be 1 minus g squared over sine 23. We saw that it's nothing but g. So this is perhaps how you need to solve it. I'm not too sure, but if you know your stuff, the cofunction of 10 is cot as well as its reciprocal. Very strange, isn't it? Yeah. Well, That's the story. That's the story. That's the story. How many marks? 2. So if you knew this, the reduction is good. The answer. That's if this is proposed. If not, well, I guess this step is a mark and this is a mark. Strange stuff. Anyway, let's do the last one. 3.3. This says we need to do sine of minus 653 degrees. Okay, it's a higher grade question where there's multiples of the 23s, okay? But we need to create a reduction here. So this is the same as sine of, basically, let's see, it's 360 and what? So, I think this one is a bit naughty, isn't it? Yeah, it's a bit naughty. But let's see. So this is going to be minus 360. So let's see anyway. This 356 minus 360 for the first time, we get 4. Minus 653 minus 360. Oops, plus 360. Holy cross. Minus 653 plus 360. Then plus 360. Okay. This question is starting to irritate me now in a way that I don't like. Okay, let me see. 653 plus 360. Maybe just once. It's fine. So we can safely say this is the same as minus 360 degrees minus 293 degrees. Okay? I think this is good because if we just do that, we get that number, right? Yeah. Now we can factor out a negative if we will. So this is the same as sine of minus into 360 degrees plus 293 degrees. We reduce, this is going to be minus sine 360 degrees plus 293 degrees. This is good, which is going to be 360 plus, in principle it's positive, so we're going to still state this is going to be minus sine 293 degrees. Now this is easy because 293 is basically 360 minus $67. I don't want this. Hi guys, it's 2 marks. You cannot tell me that this is 2 marks. It's not allowed. You know? 67 is 90 minus 23, right? Goodness. Yeah, this question is horrible. I don't know if there was a quicker way to this, but let's just go for it. Anyway, we're going to see that this is minus sine. We set up this is going to be basically 180 degrees plus 67 degrees. It's a very silly question, honestly. But as silly as it is, we go through it. So this is the same again. This is going to be negative, so this corrects to sine 67 degrees, which is sine of 90 degrees minus 23 degrees. This is the same as the cos of 23 degrees, which is going to be just what we were given. Okay. Interesting stuff. But hey, there's so much that got done and we're just getting 2 marks. I cannot believe it. I cannot believe it. But it seems like this ultimate reduction is key and how it was given. So I suppose that's it. The rest is your problem. So again, this is where you see a little bit of unfairness on the examiner's part, unless I'm missing something that could have been done. Some people are told to just add 360 anyway. So you just add 360 here, you're going to get this 293, right? Right. So it's going to be minus 293. And then you deal with it this way, perhaps. And eventually would end up there, I suppose. But whatever. These are easy 7 marks after all. Although you would see that there are some challenges that you're going to have to deal with. But they're not too bad. You cannot cry about them. Question 4. Now question 4, we're told to simplify without using a calculator. So these are very nice questions. So 4.1.1, we've got cos 390 degrees divided by cos of minus 30 degrees minus the tangent of 360 degrees minus x times cos of 180 degrees plus x times cos of x minus 90 degrees. All right, so this is equal to 390 is the same as cos of 360 degrees plus plus what? Here when plus 8 haibo because I'm getting as well as ubala haibo. So cos of a negative angle is the same as like that, so we deal with it nicely. But I like to always reduce in one step, you know, so that I don't end up with a lot of a crisscross that I will not track nicely. So some things we just leave as they are. So tan of 360 degrees minus x times cos of 180 degrees plus x times cos of x minus 90 degrees. Well, I knew the space was going to be a bit of a situation. So this is equal to, we reduce 360 plus in principle first quadrant. So this means same function. Cos 30 degrees divided by cos 30 degrees minus. Now we can reduce this. 360 minus, it's in the fourth quadrant, so it's minus 10x times cos of 180 plus, it's minus cos x. So this one, cos of x minus 90, that's in the fourth quadrant, so cos is positive, so the cofunction sign is going to be positive. But if you want, you can just factor out a negative. It's going to be 90 minus x. Cos of a negative in general is positive, so cos of 90 minus is going to be sine x. Okay. Now we know that the gymnastics take care of issues. That is nice and easy. And then we continue. We have 1 plus negative times positive. It's going to be plus 10x, right, into minus cos x into sine x. So this is still equal to 1 plus, we change this, it's going to be sine x over cos x into minus cos x. Perhaps we now show it as a fraction to avoid issues. Sine x over 1. Okay, these are very critical steps to make sure you are as meticulous as you can. So gymnastics again take care of issues. Nice and easy. So what do we have now? we end up with positive times negative is going to be a negative, right? Sine times sine is going to be sine squared x, right? All over 1, nice and easy. So using our identities, we know that this simplifies to just cos squared x. A very nice and packed question. Alright, so what is the story, guys? This reduction is good, that reduction is good, that reduction, and that reduction. Can you see? 1, 2, 3, 4, 5 marks. Okay, using the 10 identity, 6. So 1, 2, 3, 4, 5, 6. And then this becomes 7, and using identities at the end. Nice 8 marks there. So please master this. Now there's something I call the 3-step approach when we're doing simplifications. In fact, trigonometry is nothing but algebra, and in maths in general, we are doing 3 things. Whenever we solve a mathematical problem, it's just 3 things. 1, we are doing BODMAS or BOMDAS or PEMDAS as you see it or hear it. Second, we're doing factorizations. Okay, now there's 3 of them. Usually we take out the highest common factor. We can do difference of 2 squares. We can essentially do a polynomial, or just say polynomial. The commonest being a quadratic trinomial. Then the third thing that we do, we can use identities, laws, formula, logic, etc. Okay, this is maths in general. In trigonometry, we tend to use identities, but you will see in some videos I have shown in the channel that sometimes you end up with some exponential laws for some higher order questions, especially when trying to complicate a simple expression in a way. In identities, formula, we've always been using it. The quadratic formula may be used here eventually at some point using trig equations when the final expression becomes a quadratic trinomial, so to speak. And of course, BODMAS, I often say with trigonometry, the BO, which is the brackets of part, branches into reduction formulae or core functions. This is when we apply BODMAS in trigonometry. And when we're dealing with the AS part, I often mention special angles. Okay? But in essence, we still use it as brackets, ordinals or exponents, division, multiplication, and usually here we use it to divide factors to 1. And 1 is a multiplicative identity, so it literally just sits in the background. Okay? So these are the 3 things. And if you follow here, what did we do? We saw a lot of stories here. This was big. We set it up first for reductions. Can you see? Now we introduced brackets. And guess what? We deal with brackets first. BODMAS. After here, we used reduction formulae. Nice and easy. Reduction formulae, first step. So this is step 1. Applying BODMAS. Secondly, what did we do? We went to identities, because once we sorted everything, we saw that 10 had to be changed. So we hit identities, which is step 3. Right? And from here, we then went DM style, BODMAS, division and multiplication. Nice and easy. And it landed us up here. From here, we saw that these sort of work out as identities again, the square identity. And we got to our answer. So 3-step approach was employed here. So if you think about it that way, you will always know how to solve these trig expressions without pfeffering around, going where you should not go and ending up stuck somewhere. If you follow that step, you keep asking yourself at this step, what can I do in terms of this 3-step approach? You will choose the best approach, trust me. It will always fall into place. But of course, you can convince yourself by trying it on. And if it doesn't work for you, then you can abandon it. If you do see it work, then you can adopt it. It's up to you. Anyway, I'm just showing you a technique so that you can solve any mathematical problem with a bit more confidence than just going through the motions, or essentially trial and error. This is not trial and error. It's a structured approach, and in fact is exactly what we do in essence. So you may as well think about it that way, but it's up to you, of course, as I said. So now this is sine 120, 330, and we can see all of these angles. They look like special angles, right? Right. We then set them up for reduction. Sine 120 is 180 degrees minus 60 degrees times the tangent of 330. This is more like 360 degrees minus 30 degrees divided by cos 240. This is 180 plus 60 degrees, isn't it? So here you're using special angles. Nice and easy. Of course, we're still going to be employing reduction formulae, because we need to set this up for reduction such that we end up with special angles. So this is going to be sine 60 degrees. Sine is positive in the second quadrant, times this one becomes minus 10 of 30 degrees divided by this becomes minus cos 60 degrees. Now we've got special angles. We substitute sine of 60 is root 3 over 2 into minus 10, 30 is it root 3. Let's just remind ourselves. Now remember these triangles. We've got 90, we've got 60 degrees, we've got 30 degrees. Adjacent to 30 is going to be root 3. Opposite is going to be 1. And then the hypotenuse is 2. I think this one is the easiest. In fact, it's the trickier one of the two, because the other one is the 45 degree one, where this is 1 and 1. And then this is square root 2. Remember these two triangles. They are very important, 8 when it comes to this. Now let's see, 10 of 30. 30 is basically opposite over adjacent, so it's 1 over root 3. So this is 1 over root 3. Okay, so all of this is divided by minus cos of 60 is a half, right? Because cos is going to be adjacent over hypotenuse. Okay, so it's the tangent of 60 that is root 3, because it's going to be opposite over adjacent. Okay, good. So I will again try to highlight how we used the three-step approach so that you can be convinced. Of course, I'm using my head now because everything is second nature. Of course, when we multiply this and that, will take care of each other. So we end up with minus a half. Okay? Now we're dividing by minus a half. So obviously, these ones kind of do it nicely. So the answer is 1. But let me just show you now a more arithmetic approach. So essentially when it's like this, because it was not too obvious that we're going to have a half there, so we could cancel nicely. So we ended up extending it. So negative times a negative is positive, a bit of grade 8, you know. Yeah, arithmetic. So let's see, how did we use our three-step approach here? First, we set up reduction formulae. We need to set them up. So this is a critical step, because we cannot just end up here. It means we used a calculator if we come here. So we need to show this first, although it doesn't get a mark. So step 1, reduction formulae. And you get a mark for this reduction, and that reduction. Now once we saw these reductions, we went to special angles. Still step 1. A is part applied. So I guess how many marks are we scoring here? Just 4. Good. So I can simply say, well, we can get a mark here for using special angles, I suppose, in general. And The rest of the arithmetic gymnastics are not key. This should have been 5 marks though. It's not enough for 4 marks. It's not enough. So I can reassign this one as 5 marks because we cannot ignore using special angles because, come on, they're not given. You need to think about them. Anyway, sometimes the examiners do their own things. We cannot cry too much about what they do. So 4.2, we now need to prove identities. So we've got cos x times tan squared x, all divided by 1. Oops. Over, wow, this is a complex thing. Okay, this is divided by 1 over cos x plus 1. And then we're going to add cos x, and we need to prove this is equal to 1. Obviously, we take the left-hand side. It's more complex, so this is cos x times tan squared x over 1 over cos x plus 1 plus cos x. Okay, now we need to deal with this thing. This is equal to. Now, what I would like to do here is to first leave the numerator as it is. Try to get this into a single fraction of some sort. You'll get it, and this is a nightmare, but anyway, the best thing to do here is to expand this. This is cos x times tan squared x divided by 1 over cos x plus 1, and then we add cos x. It's much easier to handle it this way. So this is cos x. Now we can actually sort this up using identities. This is going to be times sine squared x over cos squared x. Right, this is for the tan part, and then we can change this. But perhaps before we change it, let's leave this. We use the common denominator story here. This is going to be cos x divided by itself, so we remain with this one. Okay, this is over 1. Perhaps let's show it like that. So we handle things sequentially. Maybe we can say this is over 1 now. Nice. So we continue. We know that gymnastics, this is going to take just the square there. Nice and easy. So we remain with just sine squared x over cos x. Now we can convert this. Say this is going to be times cos x over 1 plus cos x, and then plus cos x over 1. Again, BODMAS, remember, multiplication, division takes precedence. We keep going, so we end up with sine squared x over 1 plus cos x. Once we sort that out, plus cos x over 1. Again, we look for the LCM here. It's just 1 plus cos x, because this times 1 is itself. Then we end up with sine squared x plus. Then we're going to end up with this one divided by 1 is going to be this times that is going to be cos x into 1 plus cos x. Alright, so we deal with that numerator. So this is sine squared x plus cos x plus cos squared x all over 1 plus cos x. Now we've got like terms. Sine squared x from our square identity gives us 1 plus cos x over 1 plus cos x. And again, these now are the same term, so they will divide to 1. Nice and easy. Oh, wait. This is an identity which is equal to the right-hand side. Okay, Of course, here one may just want to leave it at 1, but I think since we used it as an identity, let's go through the steps that we had to follow. Now, how did we use our 3-step approach here? Of course, I'm not trying to waste time this time. Just want to solve and then highlight where it came into effect. First of all, we didn't do anything here. We just expanded our expression to make it ready. So this is just preparing our expression. We had not done any gymnastics whatsoever. But from here on, we realized that we had to use identities. So this is step 3. This is how we started. Step 3, we used identities here. And which other step? Using fractions. Remember, we treat this as some kind of, addition and subtraction. So this is the AS part of BODMAS. So this is 3 and 1 together here. And then what did we do? We still followed step 1 here. You see, when we deal with factors, DM section, this is step 1, literally. And then what we ended up with is again addition and subtraction of functions, which is again step 1. Found the LCM. Sorry. And then did the gymnastics in a way, but perhaps let's write it down here. Let's write it down here. Okay. From here, what did we end up with? Of course, here we used brackets. Remember, brackets come first, so we need to do BODMAS again. So still step 1, the standard way. Then when we got here, we had to use identities. So yeah, maybe let's get rid of this one. Here we had to use identities, which is step 3 to get us there, and then again BODMAS to get us to the answer. So can you see, we're alternating between step 1 and 3. In a way, this helps to understand how to go about business here. So how many marks were on offer there? 5 marks. First of all, turn identity. It's a critical step. We get a mark for this. Using identities here to get this 1, that's another critical step, essentially. Now we think about it. There is too many things we had to do here. So these marks are also going to be part of those gymnastics. Now remember, this whole thing came from that. So we can mark it that this is a very important step. Right. And then, of course, once we get to the step, this part is key. So how many marks do we have? 1, 2, 3, 4. And of course, to show that this is equal to 1, I suppose that's good enough. And if there is any other place I may have forgotten, well, you show me, guys, but that's the story right there. Okay, so identities, these are easy big marks. Please make sure you don't lose. So let's do 4.3. It says, given the expression, again, cos 2x plus 10x. Of course, in grade 11, you don't do double angle identities, so you're going to have to find a strategy here. It says, determine the value or values of x in this interval for which the expression is undefined. So can you see, all of that is not really important, because for something to be undefined, it means the denominator is what is key here. So for 4.3, we know that, well, we're given cos 2x times 10x. So this is not part of your syllabus in a way. Sine squared x. Now we can say, for the expression to be undefined, for the expression to be undefined, it is such that sine squared x must be equal to 0, isn't it? Yes, and yes. Because once the denominator is 0, remember, this is a rational fraction, more like, x times whatever divided by, x, and x cannot take 0 in that math because this division by 0 is undefined. And that's exactly where the question is. So they just give you something to scare you. But if you look at it, you're just supposed to focus on the denominator and nothing else. Alright, so here there's nothing really to do. You just take the square root on the one side and you take the square root on the other side. So this implies that sine x is equal to 0. Right? Therefore, x is going to be arc sine. Right? It's going to be arc sine of 0. Now, I like the general solutions approach here. But some of you don't really care, but I like it because it makes life easy. Plus k times 360 degrees, or x is going to be 180 degrees minus the arc sine of 0 plus k times 360 degrees, where k is an element of integers. I find this approach very, 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 very useful. Just make sure you get used to it. So this means that x is equal to 0 degrees plus k times 360 degrees, or x is going to be equal to 180 minus 0 is just 180 degrees plus k times 360 degrees, where k is an element of integers. Now you make an answer. Therefore, x is equal to this set. It's going to be 0 degrees, right? Because 0 is included, and 180 degrees included. Okay, nice and easy. Of course, we're given the domain and we sort it out. Very easy. Don't worry about the squares. They don't matter. Because whatever this is, sine of 1 of 0 is 0. Whether you square it, it's still going to be 0. Sine of 180 is 0. 0 squared is still 0. So, easy. So what is the key here? Is to write up this part. To know that the denominator has to be equated to 0 in those solutions. Remember, the general solutions here were the means to an end. So you're not getting marks for it, but I would prefer you do that, because for repeating solutions, you may be caught out if you just focus on 2. Be very careful. So I'm just showing you a careful approach rather than the only approach to think about. Some people may just say reference angle, 0, whatever. It's not a big deal after all. Then look at the quadrants involved, but some expressions have a tendency to scare people, so you don't want to be caught out. So solve for alpha and beta if this is what we have. So cos of alpha plus beta, again in grade 11 we don't normally deal with compound angles, so this is to suggest that we're not going to expand this, we're just going to solve it reference angle style for alpha plus beta being there. Okay, and again we're going to look for alpha as well, and we sort it out. As you can see, this requires us to perhaps do simultaneous equations. It seems we're going to have to deal with this simultaneously, but at the same time, if you look at this, there's always a way of making this angle look like this angle, you know, somewhat. But let's start. We've got cos of alpha plus beta is equal to minus root 2 over 2. Okay, and we are told that the compound angle should be in the first 2 quadrants, first and the second. Okay, so what do we know? We know that, well, alpha plus beta is going to be, for me, I go for plus or minus the arc cos of what I have. Okay, plus k times 360 degrees, right? Right. Where k is an element of integers. Okay, now I'm going to do this the general solution style. Alpha plus beta is going to be equal to plus or minus, let's see, what is the arc cos of that root 2 over 2? That should be 45, but it's going to be minus 45 degrees. Arc cos of minus root 2 over 2. Oh, it gives us 135 straight up. Okay, so this is 135 degrees plus k times 360 degrees, where k is an element of integers. So this implies that alpha plus beta is plus or minus 135 degrees plus k 360 degrees, where k is an element of integers. Now remember, k here can take 0 because it's already giving us that this is plus and minus 135. So plus 135, where is it? What quadrant is this? Second quadrant, isn't it? So cos is negative. What is minus 135? Is still on the second quadrant, but on the negative angles. Again, it's going to be the same value. So this is good enough. So we can safely say alpha plus beta is either 135 or minus 135 when k is 0. Don't worry, don't be confused by the general solutions. I'm just trying not to miss solutions. Now, we need to come to this one as well. Right, yeah, this question is crazy. We can say also, we want to say cos of alpha minus 2 times beta is equal to a half. This implies that alpha minus 2 beta is going to be arc cos plus or minus arc cos of 0,5 plus k times 360 degrees, where k is an element of integers. This implies that alpha minus 2 beta is going to be plus or minus arc cos of 0,5 is 60 degrees, right? Plus k times 360 degrees, where k is an element of integers. So therefore, maybe let's make a conclusion. Alpha minus 2 beta is going to be plus or minus 60 degrees, where k is an element of integers. Okay, now what is nice is that we know that plus 60 is in the first quadrant, cos is positive. Minus 60 is an angle in the fourth quadrant, again cos is still positive. So essentially, what we know is that we only choose where cos is positive and where cos is negative. For the first one, we need those two solutions, right? But for the second one, we only need one solution. Can you see? Because this is up to 180. So this means here, this angle, we only choose the plus 60 degrees. We don't need the negative one because this is in the fourth quadrant, it's outside the domain. Okay? So here we don't put the plus negative at this point. It was just a means to an end, but we're choosing the positive one. So here we can just drop the sign altogether. But for the first one, perhaps the first one also is the second quadrant that we need to worry about, because when we do negative angles, we're going to change the domain and include negative angles. So this one is also out. Okay, good. So can you see, you look at the structure eventually and see what to do. And we know that k here is still going to be 0, so that it works out nicely. So what are we going to do? Now we've got simultaneous equations. We know that here, it tells us that alpha is going to be 135 degrees minus beta. Right. So we can say safely then, in fact, we can make this equation 1 and make this one equation 2. Okay, maybe we need to drop this business here. It's not helping. We can just drop that and make this one equation 2. So we can say we can then take 1 into 2. What are we going to have? Alpha, we saw that it's going to be 135 minus beta minus 2 beta equals 60 degrees. All right. So this implies that 135 minus 3 beta is going to be 60 degrees, which implies we take beta to the other side, it becomes 3 beta equals, we take 60, it's going to be 135 degrees minus 60 degrees. So 3 beta is, let's see, 135 minus 60 is 75 degrees. Therefore beta is going to be 75 divided by 3, which is 25 degrees, okay? And therefore alpha is going to be 135 minus beta, okay, which is going to be equal to, let's see, it's 110 degrees. Okay, so that's it. Quite an interesting question. I may have chosen the long route, maybe, it's possible, but yeah. I think, how many marks? Just 4 marks. Of course, you could not have thought of general solutions. Maybe you could have abandoned them. It's okay. It's all right, but this is it, okay? This is it. So let's get the marks. So where do we get the marks? I would suppose this is key, this is key, and the actual answers, it seems. The rest is your problem. Alright guys, so yeah, that was a bit of a naughty question. I would call it a higher grade question because you don't see it coming unless there's a better way of dealing with it. Now let's hit Euclidean geometry, which is what you guys know how to do. So in the diagram, O is the center of the circle, AB and AC are chords, and BO and CO have been drawn. Of course, this is to prove the angle at center is equal to 2 times the angle at circumference. Now in grade 11, you were taught this in class. So your construction, you just draw this diameter. Alright, what I prefer is to hit the circumference with my construction rather than to leave it hanging. Okay, so I just say draw AOD. Okay, so your construction here, you must dash it to show that it's a construction. Otherwise, if you make it a solid line, you're almost suggesting that it was given and you'll be in trouble. So this divides A into 1 and 2, as well as O on this side as 1 and 2. Leave the 1 on the inside, it's not important. And what you base this on is that these are ready. So those are isosceles triangles to suggest that this angle must be equal to that angle. The angles opposite equal sides, and this angle must equal that angle. Alright, so essentially isosceles triangles. Now what you're going to use is the exterior angle of a triangle, is that this angle plus that must give us this. Right? Great. And the same story is that that angle and that angle must give us that. Perhaps let me change the colors here so that we don't suggest that they are equal. So you're going to use this triangle to find that brown angle. And then we use this triangle to find that angle. And as you can see, O1 and O2 is BOC, right? Right. And then 2 times BAC is nothing but 2 times angle A. I'm not going to show you the proof, guys. It's in your textbooks. And your teachers have gone through these in class. So if you are one of those students who depend on seeing this from different people, but it's there in your books, then just know you are in the wrong subject, okay? What is in your textbook, you have no excuse not knowing it off by heart. If you don't, then it means you're not serious with your life. So please, leave us alone. So question 5. So we're starting with question 5.2. Now this one may not be in your textbooks, so we need to show you the strategy, right? But we should not. Anyone who does this again and again is not serious themselves. Anyway, 5.2 in the diagram below, DF is a diameter. Very important story. So if this is DF is a diameter, so what do we know about a diameter? It subtends a right angle. And funny yeah. That means angle DEF must be a right angle. Angle in the semicircle. Okay, of the circle with center O. Okay, nice and easy. So if this is the center, no, this is the radius, radius, radius. So it means those are isosceles triangles. And if they are, we already know that this is the angle that is equal to that angle. And we know that that angle is equal to this angle. Okay, annotate your diagram cleanly in such a way that you don't hide the information that was given, and also make it clean so that you can look back without needing to rub off these things. So I'm showing you all these things, folks, so that you can learn how to do this thing in the exam and not rub off, because I see you all, you have your sketches messed up, you rub and you write, you rub, right, so that you don't need to rub off. At the same time, you'll still be able to see everything as it was given originally, okay? Let the annotations not distort the diagram and not destroy the diagram. Of course, on some special occasions, you may end up needing to rub off, but if you do that, just know you're going to have your thinking messed up, because everything is going to be disjointed again and you will lose out. Trust me. If you ever find yourself needing to use a rubber after annotations, just know you are lost. You will most likely fail Euclidean geometry. Okay, chord EG intersects DF at H, okay, like that, such that GH is equal to HE, so it's already indicated. But now what do we know? A line from center to midpoint of chord, what does it do? Bisects the chord, sorry, to midpoint of the chord. It is therefore perpendicular to the chord. So we know that this angle is 90 degrees. We just need to show one. We don't need the second one. It's not a big deal. But depending on what area we're going to have to work with, we may have to change ourselves and add the other one. But again, you can even show it like so, because this is a chord, so it's a straight line. So if that is 90, the other one should be 90. So you may as well just show it bilaterally or unilaterally. It doesn't really matter. But I prefer just once so that I don't mess up the diagram. Great stuff. So now we need to use a different notation for this, because those singletons have already been used. So we're not wanting to suggest that this is equal to that, because a student who's careless, once annotating with just a single line, they would be forced to think this is also an isosceles triangle and end up in a curve out of commission. All right, chords EF and GF and DE and the radius OE are drawn. EGF is 55 degrees. It's nicely indicated, so we're not going to stress. But now what do we know about that particular angle? That particular angle is equal to that. Why? These are angles in the same segment subtended by chord EF or arc EF. So this already tells us that we have 55 and then we have 55. And therefore we can work this out, because this is 90 minus 55, which is going to be what? It's 35. So folks, be in the mood to showcase things. And now that is 35, this is also 35. So these are things you need to justify, but you want to make it easy for yourself. Annotate the sketch as cleanly as possible. How many minutes were we supposed to take down this paper? Because I'm feeling like, wow, 2 hours is over. But of course, when doing this, guys, it wouldn't go as long as I did. Of course, you just try to speed up a bit. At this point, I'm trying to use this as some form of a review so that you gain the best way of doing things rather than just to chase time at this stage. Remember, you start off by looking at things, knowing how to get the job done. After that, you work on time, isn't it? Because even a person who wants to train for a marathon, at first, they just build up on their endurance. They don't really care about the time. They build on their endurance so that the body can take it. Then after that, they start doing time attack so that they can beat certain times that have already been beaten before, so that they can break records or at least make it. So you don't start by attacking time, because if you start doing that, guess what? You'll be demotivated. You will feel sore. Your body's not going to take it and you will fail. Okay, so don't do things that are going to automatically take you to a fail, because you get this notion that you need to be fast. Yeah, that's true. But how can you be fast if you don't know already what to do? But if you start knowing how to do things effectively and successfully, you start seeing things as hidden as they can be given, then you can speed up. It's automatic, I can almost tell you that. To speed up is automatic once you know you've built up your endurance. But if you start by running fast, then you'll always be missing out. You'll always be making mistakes and you'll always live to regret. But hey, just showing you, it's up to you what you do with what I'm showing you. Write down the size of D. Can you see? Question says, write down. Provide a reason. So at this point, we don't need to really, I feel like I hate this way of asking for Euclidean geometry, honestly speaking, because I don't like a student who's just going to write D is equal to 55 degrees and then angles in the same segment. With which angle is this angle D in the same segment? You know, I hate this kind of questioning. It's immature. It's immature of the examiner to ask a question like this. It's really wrong. Anyway, whatever. It's just my take. Doesn't have to be your take. So the way I like it is to say angle D is equal to angle G. First, these are angles in the same segment. Right? Right. Therefore, angle D is 55 degrees. This is for me the way. Someone must just say determine. The best here is to say determine. This thing of writing down and then have a reason, a disjointed reason, it really irritates me. Of course, there's only 155 degrees that is given for now. It's okay, it sounds forgivable, but it's wrong in the long run. Cryptic statements don't make sense in my opinion, and they should not be accepted. But hey, whatever. So according to the examiner, I should write this and this reason. This statement, please, according to the instruction, don't do it. I'm just showing you the right way of answering. provided the right question was asked. This is a ridiculous question. So unfortunately, a ridiculous question needs a ridiculous answer. Unfortunately, you have to still follow the local instructions. They take precedence over what we know in general, and even the general instructions for that matter. So unfortunately, I'm just showing you the right way, but please adhere to the instruction. Ask a stupid question, please give a stupid answer as well. If you give a smart answer for a stupid question, you will fail the question, unfortunately. Anyway, I'm being a bit brutal now, but sometimes you've got to be, so that stupid things must just flush out. If we don't call them out, they will stay in the system and contaminate the entire system in the long run. Then we will wonder how we ended up somewhere where we did not want to go. It's because of silly things like this that we allow to become a common thing, or a common finding in our societies or in our systems. Then we wonder why we end up deteriorating in the future, because we set ourselves up for failure by accepting stupid things. It's like, okay, let me not talk about these things, but because it will sound too insensitive of me to say, but I already have a lot of examples of what I want to talk about. And society is contaminated as we speak because we accepted those stupid things. Let me just take a milder example of these things. You know, there's this thing of, after tears, and people go drinking and party when somebody has died. I can tell you guys, this has led to so much societal breakdown. I was appalled, even in our family. Even within my family, we had a funeral not so long ago. Man, I cannot believe what I see. People buy alcohol like we're having a ceremony. I would understand if this was a ceremony, maybe of remembering someone who's long gone. Remember someone who's long gone, we're no longer mourning them. We're probably celebrating their memory. It would be appropriate to have alcohol if ever tradition dictates as such, or people choose to, right? But when we are in mourning, we have just suffered a bereavement, and we are now in the process of burying that individual. We are still in mourning, but people are already celebrating. How nonsensical is that? And you wonder why society is so lost. People don't know what's right and wrong. They just do as they please, but when they go into problems because of what they do, then they start to say the world has changed. In essence, they are the reason the world has changed, because they are actually what changed. The world remained the same pretty much, but the people in the world are the wrong ones. But because societies started slacking on rules and regulations, for the greater good, of course, not necessarily to oppress, but for the greater good. Anyway, folks, you take it with a pinch of salt. I really don't care how you're going to feel about what I just said, but for me, that's not how I was raised. Perhaps it could be a cultural thing, or we can say it's basically an environmental thing if we want to separate environmental, or should we say geographical? Perhaps that would be the correct word to say it's a geographical issue. I was raised in a community that never accepted nonsense and accepted it just because people can choose to do it and it's their lives. We can accept that. No. If something had something to do with a very bad, perspective of our society, it was punished. Of course, if you wanted to maintain your own choices, you would be banned from that society so that you can go and live somewhere else where you can create your own detrimental future, or perhaps degrade that society you're going to go into if it allows you. But this one that we built from the ground, you don't belong there if you don't have, or at least share the same perspectives. So you would be banned, simple and straightforward. And I suppose we should do the same. If you come to maths, you do silly things. Even if you're a teacher or examiner, we should ban you from examining students, because questions like these are unacceptable in my opinion. When we're trying to build you up into somebody who's logical, this defeats logic. honestly speaking. It just goes with assumptions in a way. It kind of promotes assuming things, guessing things, because you don't display that you understand the pattern of thought needed here. Although it may be accepted as such, but do you see, we're actually making this superficial, and yet it's a deep thing. It has depth in it. But to make it so common and superficial, then we're going to lose the train of logical thinking and thought. And in the future, we'll end up with people who are just haphazard. Look at our leaders currently. They are so haphazard. You don't see form and order in their actions. And as a result, they are failing us. And we can see the results, that they're not so good when people are haphazard. But we are promoting the very same haphazardness in our students. How do we expect them to be good? Not at all. Look at the degrees that we award. There are so many, guys. But how useful are those individuals with those degrees? Hardly useful at all. And that's why they're sitting at home without jobs. We can argue that there are not jobs available, but reality, if we can just do a serious reality check, 80% of those graduates are useless. They are not employable. If you want to integrate people into a system that works, they will break the system because they are nothing but liabilities. And that's what we have right now. Now we start crying, institutions are toxic. That's what people say. Okay, maybe to some extent. But has this toxicity led to a breakdown in the past? Because this toxicity people call out today has been there before, and it produced the best. We were able to be proud of ourselves. But now that we're slacking on those kinds of things, we're starting to have a society or people that we're ashamed of instead. And that tells you something. It's not toxic. But if you look at it in terms of a sentimental perspective that is individualistic in nature, you will always say things that are actually progressive. They are toxic and they must be called out. Yes, they will be called out because society is lost. In the end, you will be crying off some difficulties in society. You will forget that you actually are the very reason for those, because you stopped what prevented these things. Just because nobody told you these things are directly linked to that prevention, you wanted someone to say it first before you could see it. Even then, people stay in denial. Hey, guys, I'm going off in a rant now. I'm actually getting pissed by the fact that we're allowing things to go wrong just because, this angle is equal to that. So if you're just saying it's this one, you are literally saying that. But yeah, true. But what if the student didn't say this, was just guessing? What if the student was guessing? Because this angle could be any other angle here. What if the student is talking about E2 plus E3? What if E2 plus E3 is actually the same angle? In a way, if you think about it in retrospect. Come on, guys. I don't like this. Again, here's the stupid question. Again, coming. Write down the size of O2 and provide a reason. Wow. Write down. Okay, we're gonna write down. But anyway, let's show you the right way. And in fact, the question should have been determine the following. Because there's no need to keep writing that instruction. Just say determine the following. D, O2. And there's nothing wrong with question papers looking the same, because the question here must be clear. And the actions necessary to answer those questions must tie up with the question. Don't ask questions that you would want to argue about the method in which those questions are answered. Anyway, guys, whatever. The right question should have been determined. Okay, I'm going to call it out because this is wrong. I know it is wrong. It's a seed of destruction. Lizamba nili-1 elibolileyo engqiweni. Ewe, libole lodwa. Fine. Kodwa ubukhe walishiya lazambane lihleli namanye, lizawabolisa onke. Ugqibela songasenawo amazambane wonke. Kodwa uye walikhupha elazambane kwangela xesha ubulibona balilo lodwa elibolile ulilahlelele kude. Ebezawusala la mazambane amanye right, uphinde watye onke. Ugqibela sowutye ambalwa ngenxa yezambane eli-1. Ilahleko ke le. That's a loss. Anyway, whatever. I am going to say, nice and easy, angle O2 is equal to 2 times angle G. Why? Angle at center is equal to 2 times angle at circumference. Okay. Now this implies that angle O2 is equal to 2 times angle, the size of angle G. Therefore, angle O2 is equal to 110 degrees. You get it? Now you do. This is the right way, because it also makes you logical in your approach, even on other issues in life, that you're not going to have someone telling you before on how to deal with those situations. You'll just know how to be methodical. And that way you start to strategize better. Less resources for maximum benefit, rather than a lot of resources for minimum benefit. But again, your examiners are saying all of this, they're not interested. All they want is the answer and the reason. So of course, if they ask you stupidly, answer stupidly as well, because that's exactly what they want in you. So you're getting a mark for that. Okay, not a problem. Let's go on. So 5.2.3. Calculate. That's much better. Giving reasons. Can you see, why do you have to repeat yourself? Give a reason. Give a reason. Instead of just determine this. We know in general in Euclidean geometry, you don't say anything without a reason. There's not even a need for the instruction to say provide a reason. It just shows you the person who was writing this question as immature in the subject. Okay? And unfortunately, we have many of those. Some are just careless. As matured as they are just simply careless. They don't realize that they are instilling carelessness in you, and then they later complain about you being careless students. But they are forgetting that you are actually taught this carelessness by them, although they don't realize that they are being careless, because guess what? Nobody has the guts to tell them. Well, I do, and I'm saying it now. Anyway, let's go on. Leave my attitude at the moment. Perhaps I smoke ganja, you don't know. Maybe I did, or something else. Maybe I'm irrational myself. You tell me. You be the judge. Calculate, giving reasons, the size of F2. Okay, where is F2? That one. Can you see? We already knew we were going there. And how we get there is a bit strange, but now it's just 1 mark. Wow. Okay, O2, we're going to have to use this isosceles triangle. We're going to use the isosceles triangle there. All right, so again, can you see? It's just 2 marks, but there's so much to say there. Wow, guys, we will say in triangle EOF. What do we know? We will just simply say, well, angle F2 plus angle F3 plus angle O2 should give us 180 degrees. This is the sum of 3 angles of a triangle. Okay, good. Well, there's another way, actually, a much more concise. You uncover that 90 degrees and then use triangle DEF, using sum of 3 angles of a triangle, perhaps to avoid these other issues. Maybe that would be just 3 marks, I suppose. Maybe let's do that to try and cater for 2 marks, because this is going to be a lot longer, because you will have to state that these two are equal. Okay, maybe let's show you so that you know how to do things nicely. Since we started this way, this implies that 2 times angle F2 plus angle O2 is equal to 180 degrees. And then we justify that F2 is equal to F3. These are angles opposite equal, ready, OE equaling, perhaps we can just say OE and OF in that triangle. Okay, I don't need to say it. Okay, can you see we've provided 2 reasons, and but usually this one is not a reason that gets a mark normally. So perhaps you would start to get a mark here. So this implies that 2 times angle F2 plus, we found O2 as 110 degrees is 180 degrees. Therefore, angle F2 is going to be 180 degrees minus 110 degrees divided by 2. I like to show all the steps because when a mistake has occurred and you need to trace it, it's much nicer. It becomes more friendlier for you to trace where the mistake was committed. But of course, it's up to you if you don't like that. But then when you make mistakes, you're not going to be able to trace them. You will start afresh everything. Can you see this is a lot, but it seems like this is where the mark is, specifically for doubling that. Okay? And then we can easily say, well, substitutions and whatever. 2 marks, sorry, no substitutions, final mark. Okay, that was one way. The other way that one could have done, one would say, well, D, maybe let's start saying in triangle DEF. Okay, we know that basically angle DEF is 90 degrees. This is the angle in a semicircle, right? Not semicircle. Right, so then we know that angle F2 plus angle D plus angle DEF, we should get 180 degrees. This is the sum of 3 angles of a triangle. This implies that angle F2 plus 55 degrees plus DA. Konje la DEF is 90 degrees is equal to 180 degrees. Therefore, angle F2 is going to be 180 degrees minus 55 plus 90 degrees, which is going to be still 35 degrees. And please guys note, the final answer must have the right notation. You may be careless about in between. This is why I often just make sure that small things I don't allow to ever escape any writing of mine, so that I don't miss out at the end, because that carelessness is so common nowadays. Find people saying 90 degrees is 90, and 90 could be 90 units. It could be 90 centimeters. So if you mean degrees, we need to see a degree symbol. I punish for those. Thank God I didn't become a teacher, because students would be like, wow, this guy is angry at the world, not knowing that I'm actually shaping them up for their future, which they will be proud of tomorrow, and forget who put them in that position. Because we tend to be proud of misplaced gratitudes, praising people who didn't do anything, do a bare minimum, and you disregard those who actually do the most. Anyway, whatever guys, we live in a very twisted society. That's why we use the word twisted. Everything is twisted. What should be is no longer. And what should no longer be is actually is. These runs, will they ever end? Well, I don't know. I just didn't know. So this one is a powerful statement and the reason and the final answer. This is a grade 9, grade 8 thingy. So this is why it's not so strong. Of course, it depends on the logic surrounding that reason, which would decide if at all we need to worry about it. So 5.2.4. We need to prove with reasons that DE is a tangent to the circle passing through E at E. Okay, so basically, where's the circle? Okay, guys, so there is our circle. So what are we trying to say now? Well, E, F, and H, yes. There's our circle, E, F, and H. So what this is driving us to proving is to prove that essentially this angle, it is suggesting that we need to prove that angle E1 is equal to angle F2, because this would suffice for a 10-chord theorem, this DE being a tangent and HE being a chord, and F2 being the angle subtended at circumference with that. Okay, so this is easy because we saw that this is 90 degrees. And of course, if this is 90 degrees, these are vertically opposite angles, so this should be 90 degrees. So it drives us into that triangle nicely. Okay, so as you can see, it drives us into this brown triangle. And we already know D. We will know H3 as 90 degrees using angle at center, line from center to midpoint of chord. And we work out that if it comes out as 35 degrees, then we are sorted. So now we will say safely, we know and understand that okay, let me think now, what would be the best approach? We can say E1 plus angle D plus angle H3 equals 180 degrees, right? This is the sum of three angles of a triangle, of triangle. Sum of three angles of triangle. This time we need to be specific. Triangle D. What did I do now? I ranted so much. Now, yeah, it's showing me. It's showing me. So this is good. We will say, well, this implies that E1 plus, we saw that this is 55 degrees, plus we're going to say 90 degrees is equal to 180 degrees. Why is this? We know that basically H3 is 90 degrees because of line from center to midpoint of chord. Okay? Alright, so of course one could easily say, but H3 is 90 degrees and then provide a reason, then come back. But sometimes I'm just showing you some quicker ways to still do the same thing. You want to do the logical thing, but at the same time you want everything to flow. Of course, here I wouldn't be too straight about other things. Of course, you can argue and say, but that is stupid as well, exactly how I was calling things up above. So not a problem, it is indeed stupid. But since stupid things are so common, why not? Anyway, so we know that basically this implies that angle E1 is basically 180 minus 90 is going to be 90 degrees. Okay, let me not be silly. Since I want to finish, let's just finish. So 180 minus 90 minus 55. So this is indeed 35 degrees. Okay. So we can say, therefore, angle E1 is essentially equal to angle F2. right? Because each is equal to 35 degrees. That's the only link, it's their sizes. There wasn't other logical link than just their sizes. We can make a conclusion, therefore, that indeed DE is a tangent to circle passing through E, F, and H. Now the reason this is the converse of the 10 chord theorem, right? Because the 10 chord theorem says the angle between the tangent and the chord is going to be equal to the angle subtended in the alternate segment by the chord. Now we proved that those two are equal, then conversely this must be a tangent to this circle. Nice and easy. Okay, that's a nice question after all. So of course grade what not important, but for this and the reason we get a mark, and proving that this is the case, and for the conclusion and the reason. Okay, very important. And now we score our 14 easy marks. Of course, this was standard grade questions at best. There's nothing really higher grade here. All about strategy, guys. Strategy, guys. Let's get to question 6. Wow, so many questions. Is there more? Whoa. Okay, let's quickly move. I'm not gonna rant now. I'm gonna just solve question 6. Okay, in the diagram below, CD is a diameter again. So if CD is a diameter, it means this angle K1 must be 90 degrees, angle in the semicircle. And PC is a tangent. So if PC is a tangent, we know that C2 must be equal to D, which is 40 degrees. Nice. To the circle, let's see, all right? Chord DK is produced to P. You know, in course, DK, is a big word. I don't want to mention it. Specifically, Amampondo like that word, and it's lialumeza. Okay, chord DK is produced to P. So this is to suggest this is a straight line. So DKP is a straight line. And if that's the case, this is also to say K2 is 90 degrees. Maybe we might need it, maybe we don't, I don't know. All right, PT intersects KC at Q. KC and PT, they intersect at Q. Okay, we can see that. CDP is 40 degrees indicated, and DPT is 25, again indicated. And TQC 65, okay, that also indicated, not a problem. Now what can we do with all of these? Well, we have the value for C2, right? And we would have the value for K2, that would be 90 degrees, as well as for K1. And of course, KQP would also be 65, vertically opposite angles. And how would it help us? Well, we can see that once we have a value 40 degrees, we've got 65. This is an exterior angle of this triangle. So we can work out P1, say 65 minus 40 gives us what? 20 degrees. 65 minus 40 is 25, yeah, 25. So this means this is going to be 25 degrees in case we're looking for P1. So this is to suggest that we can solve everything here. Nice and easy. And if we have this, well, we know that the tangent is always perpendicular to radius. So this is also 90 degrees. I'm going to show it nicely there. So if that's the case, we can actually work out T1. And from angles on a straight line, we can work out that T2. And also we can say 90 minus this, 40, it gives us 50 degrees. So this is essentially 50 degrees, that's C1. So we can get every angle. So always try to do this. But of course, don't annotate too much. Try to be as minimalistic as possible in that. At the same time, you will get the hang of things. You'll start to know how to strategize better. You see, calculate with reasons the size of the following angles. Why not the same question above? Honestly speaking, this is good. Rather than to keep writing and writing. Maths is not to be written too much, to be dealt with more instead. Okay, C2. Where is C2? So C2, we know that angle C2 is equal to angle T4, which is going to be, what is the reason here? This is the tan chord theorem, right? Therefore, C2 is equal to 40 degrees. Answer. But now ask me a question. Is this a calculation? The answer is no. Do you see how misplaced the statement is for 6.1? Ridiculous. 100% nonsensical. Do you understand what I mean? That the examiners sometimes they worry me as to who are they? Who are these people? Who are these people? This is more of a determination than a calculation. And now remember, the instruction is compelling. I didn't say a calculation, so I won't mark this correct. Do you understand what I mean? If you're saying calculate, I expect to see a calculation. And there's no calculation. Is there a way of doing that through a calculation? The answer is no. It's not possible. For 2 marks, of course. It's not possible for 2 marks. So I have a problem with the way questions are asked. Because if I need to provide a calculation, I need to first say this is 90 degrees, right? Right. From then on, after I'm saying this is 90 degrees, I'm going to say this plus that plus C1 is 180 degrees. 3 angles of a triangle DKC. Then work out this angle. Then from 90 degrees, subtract that angle and get this one. But do you see, that would not be worth 2 marks. So how questions are asked is ridiculous sometimes. This is why I say, when this kind of paper is allowed to go and hit the desks of students, it just shows how low the level it is that we are as the institution, should I put it that way, of education. Because honestly speaking, this is unacceptable. I have no words for this. This is not a calculation. But the question said calculate. And a calculation would not be worth 2 marks at all. It would not be worth 2 marks because there would be a mark for C1. At least 3 angles of a triangle is not a big deal. There's a mark though for C1. 2, stating that this is 90 degrees. There's a mark for that because there's a reason in there, right? That's a 2 mark. Then calculating C2, that's the 3rd mark. So you see, there's a mismatch here. Anyway, guys, whatever. So it looks like the marks here is for the statement and reason. Sorry, the reason and the answer, I suppose. 6.1.2. K1. Okay, where is K1? Again, we don't even need a calculation for 2 marks. This is a determination. So we can say angle K1 is 90 degrees. Why? This is the angle in the semicircle. Right. So again, statement and reason. Good enough for 2 marks. But now, you see what I mean? Do you see what I mean? Now, can you see in C2, we'll have used K2 as a calculation. Now we still have to answer this. Can you see how very ill-informed is this question? Not necessarily to say these are wrong questions to ask, but how they are asked is just so poorly informed. because this is to suggest that we need to see a calculation, and there's no calculation here. You understand? This is wrong. The only way to answer this, which is going to be a bit of a situation, I suppose. Maybe let's say, how would we show a calculation for K2? We can say, well, we don't know where the center is. That's another problem. But anyway, DC is a straight line, right? But now we don't know where the center is. That's another issue. Because we could use angle at center equal to 2 times angle at circumference. So we could say, basically, now we don't have a center. See, that's the problem. If we would assume T is the center, we would say perhaps DTC is equal to 2 times angle K1. Say angle at center equals to 2 times angle at circumference, right? This would imply that this is 180 degrees is equal to 2 times angle K1. Therefore, K1 is going to be 180 divided by 2, which is 90 degrees. Now, this is a calculation. But of course, this is when we assume T is the center, because we don't have a center. Or we can even say say we've got what? Let's just say let S be the center of circle. So we can say, well, we would assume that this is S so that we can use S instead of T, because this doesn't stop us from naming something, you know. It doesn't stop us. So can you see what I'm trying to say, guys? I don't understand who sits with these papers as the quality assurer, and do they even think about these issues, or they just say, okay, the paper has been submitted, go print it out, disperse it to the districts, let them write. Because these are provincial papers. Okay, maybe district papers, I'm not too sure. But if it says KZN, it's a provincial paper, in my opinion. So this means they just distribute one. But as quality assurers, they are not people who qualify for those jobs. Politically, so to speak. And then they go and sit there and smile. When you come and ask questions, they would not provide answers because they don't even know what you're talking about. And then we wonder why we have a society like this. Because everything is sentimental. Okay, let's not go there because I'm going to sound a little less mysterious. Oh, akamba. I don't. Kalaza la way, man. Katungum faz. Well, is it so? Or would it be a comment to try and degrade my position, perhaps? Because is this me being petty? I don't know. Guys, our job as, let me just say, presumed teachers, we are now in a position to show something in a more formal way, should I say. It is my responsibility to not mislead at any cost. Yes, I may have people falling off, you know. I may fall off some people's favorite list by what I'm saying right now. But it's the truth, and you cannot apologize for the truth. Anyone who apologizes for the truth is a liar. And that's not someone fit to be looked at or recognized in society. Those are people to be forgotten, to not be attended to, or should we say, those are people not to pay attention to. Because we cannot have snakes who slither their way through. We need a straight line from point A to B, vectors. Because those save us time of running around in circles, and we get to the point within reasonable time. And everyone can see where we went, and they can follow us easily. And so vectors are better than scalars. Now we have scalars sitting in positions of vectors. And where will the vectors go? And in fact, don't insult mathematics people by letting poorly trained examiners to examine. Remember, there's nothing wrong in taking someone novice so that they can learn how to examine. But remember, those people need to see, they need to be deputies or assistants of the real examiners. Then they need to be tried. You give them a mock paper, that set a paper, and let's see. You look at it, you correct them on where they're going wrong so that they can know how to put a paper together. Then once they pass those stages, only then you can allow them to examine. At the same time, you must have the right quality assurers in place. You cannot have a novice examiner and a novice quality assurer. What are you trying to achieve? Honestly speaking, what would you hope for? Anyway, guys, yeah, whatever. P1. All right, where is P1? We see that, oh, we see you. P1, we're going to use this triangle. So we're going to have to think about this triangle right there, because that makes it easy. We already spoke about C2. We have that one given. So P1 falls into place nicely. So I can say in triangle CPQ. What do we know? We know that angle C2. Okay, what do we want? P1. Okay. Yeah, let's say angle C2 plus angle P1 should give us angle. What was that angle given as? TQC. Right. Now, this is the exterior angle of a triangle. This triangle we're talking about. So this implies C2, we already found out, is 40 degrees. Plus angle P1 is going to be equal to 65. Therefore, angle P1, we saw that it's coming out as 25 degrees. Nice and easy. Now we can see this is a definite calculation. So now this is a proper question. I'm going to write it green. This is a proper question for the general question. Now that is the only thing that aligns here. So far, this is good. Now this statement and reason, very important, final answer. Good. But where's the calculation here? Perhaps the reason is also too weak. It's a grade 8, grade 9. I would say this show of a calculation is good enough, but remember, reason is still very much an interesting portion of this, so let's leave it at that. And this is 6.3. Again, pay attention. Remember, we need to number our answers correctly, because if we say 6.1.4, that's 0, okay? So 6.1.4. We need to prove that TC is equal to QC. Now, obviously, this is to say prove that T1 is 90 degrees. Yo, hey, andazi bendiye ndavala xa bekutheni na Nkosi yam. Yo, guys, I don't know, I kind of stopped the thing and then I started working. Now I don't know what is missing. Whatever, guys. Say ranting too much, I'm losing myself in the process. So you can see the solution for 6.1.4. I think that's the one I may have not shown. But I think when I was showing those triangles, yo, guys, I hate what happened here. Because I'm busy talking, but I don't realize my video is on pause. Lord. Yikes, this is so wrong. This is so wrong. Yo. Hayi guys, angisazi nami sewenzakaleni la. is a problem. Okay, let me just take you through 6.1.4 because I want to believe that's the angle I probably did not showcase. I'm not too sure anymore. When did I stop? I don't remember. Okay, let's just take you through question 6 again because wow, this is so bad. Well, we said here, given all the analysis that we gave, C2 is essentially tan chord theorem, right? It's 40 degrees. We understand that K1 is 90 degrees as an angle in the semicircle. And this is no calculation. So our rant was that these questions are inappropriate for those two. If at all, we would show a calculation, probably to use angle at center because there's a calculation 2 times something and dividing numbers makes sense, right? But again, we would have to let S be the center because we don't know the center. And then we go on to CPQ. Triangle CPQ. CPQ, this is this triangle over there. Our task was to find P1. So we knew that C2 plus P1 would give us that angle, 65 degrees, as an exterior angle of that triangle. This is good. So this question was good for that question. Nice, 25 degrees, done. Then we were supposed to find TC as equal to QC. So I think when I tried to highlight here, kind of went into a pause, that kind of created a nightmare for me. So we saw that the main triangle is going to be TQC. Now, how do we use this triangle? We need to prove that T1 is also 65 degrees because if this is isosceles, then these sides are going to be equal. Then we saw that, well, T1 comes nicely from this triangle, DPT, because we've got that angle and that angle, so the exterior angle is going to be the sum of those. So we kind of used that knowledge that T1 is actually D plus DPT, exterior angle of that triangle DPT. We're using it as a means to an end because T1 belongs in this triangle. Then we will say T1 is 40 plus 25, which is nice, a calculation again, so it fits the question nicely. Okay, and we went about our business and found out that indeed that T1 is 65 degrees. If that's the case, we then linked the two angles and then finished a conclusion with a reason. So that's probably what was missing. And then we went on to this question, which typically is a higher grade question. So I don't know how long the pause was, guys. So in the diagram below, O was given as the center of the circle. PTR, meaning those are concyclic points, and that's the center, all right? And then we were told that N is a point on chord PR such that ON is perpendicular to PR. If that's the case, we know that PR is cut in half at N because a line from center perpendicular to chord bisects the chord, okay? And also told RS and PS are tangents to the circle at R and P respectively. We know that tangents from the same point to the same circle are equal from their point of origin to their points of tangency. Any further continuation is immaterial, okay? Now we know that this creates an isosceles triangle PSR, which means that angle is equal to that angle, okay? 62 degrees. So literally that's what we had, and of course we knew that OR should be perpendicular to RS because the tangent is always perpendicular to radius. Nice. That's what we stopped at. Then we were supposed to find NOR, and we saw that NOR is this triangle ONR. But now we can use this angle and that angle to find that small angle, which I used an arrow, and that's what we did right there. So we said PRS is equal to RPS equal to 62 degrees. Angles opposite equal sides with tangents PS equal to RS from the same point outside the circle. Then we went about our business that also we understand that this relationship of ORS is 90 degrees, but using those angles conveniently. We then went about our business and found ORN as 28 degrees, right? Then we jumped into the main triangle so that we can find our NOR, okay? So this is where we are right now. Using sum of three angles of this triangle, we need to specify triangle ONR, okay? Good. So this implies that we found that this one is, this is the one that we want, plus ORN is 28 degrees plus ONR is given as 90 degrees, okay, is equal to 180 degrees. Therefore, NOR is going to be 90 minus 28, literally. So it becomes 62 degrees. Okay. So this is good because then it's suggesting that this is a cyclic quad. PORS is a cyclic quad because angles that would be in the same segment are equal. So always think of the implications as well. You wouldn't say that before you have proven that they are equal though, because you can't say they look the same, but there's no direct link, so you're not gonna go there. All right. Okay, all right. So what are we going to say? What are we going to say? Nothing. We need to calculate the length of the radius of the circle. So the radius is OR essentially. Okay? So how do we do that? Well, we see that we have a right-angled triangle ORS. We've got this side, we've got partially that side. But what is key is that these are ready. These are ready. OR is equal to OT. Why? They are ready. So this means we can replace this in there, nice and easy. So we're gonna get into that triangle and start working our business nicely. So 6.2.2, we know that in triangle ORS, since we already spoke about that angle being 90 degrees, we're not gonna say it again. We know that OR squared plus RS squared is going to be equal to OS squared. This is from Pythagoras theorem. Great. So this implies that OR squared plus RS is 15 squared is equal to, this one OS is made up of OT plus TS. Then that should all be squared. This implies that OR squared plus 15 squared is basically 225, isn't it? Just double check. Sometimes I forget. Yeah. 225. This is a length. See? Now you cannot put degrees. OT, what is it? It's OR. Because those are ready. Plus TS is 9. All squared. We finish a reason here that OR is equal to OT because these are ready. We need to keep track of our business. So I was substituting OR for OT. Now we know that we have OR squared plus 225 equals, this is now a binomial, so this is going to be OR squared plus 2 times 9. So OR times 9 is OR, right? 9 OR plus 9 OR is going to be 18 OR. So this is going to be 18 OR plus 81. See? Trinomials. They will keep haunting you if you think you can get away. Now OR is of the same sign on either side of the equation, so when you transpose, it goes away. Nice and easy. And now all we need to do is to isolate this OR. So we know that 18 OR is going to be 225 minus 81. Maybe let's write it nicely. Therefore, OR is equal to, mind you, OR is the radius, so it comes out nicely. We're going to know that it's 225 minus 81, giving us 144 divided by 18. So you can say therefore the radius of circle is going to be equal to, divide that by 18, it's 8 units. Okay, that was a nice higher grade question because many students would fluff it here. So you need to see things, guys. That's the essence of it. I'm just sorry I kind of went into a pause without noticing, and I kind of went into solving, but I tried to trace everything, so I'm sure you were able to follow. Because those are important questions to deal with. Nice and easy. So for 4 marks, where do we get the marks? Okay. What is important here is this step, right? When we replace OT with OR. And, of course, the answer, mind you, we need to state units. We can't just write 8. So that's 2 marks. Now, where's the other mark? Well, we can safely say substitutions into the Pythagorean theorem and writing it up as well. Looks logical there. It looks logical. Okay, that was easy. Nice 17 marks, but it's only easy when you know what to do. When you don't know what to do, this looks horrible. Okay, let's get to the last question quickly. I'm already way beyond the time I'm supposed to spend here. But again, it's not a time attack thing. It's a revision. So a revision, you need to give it time because it's too many topics, but you need to understand how to use what you already know. Okay, question 7 reads, in the diagram, O is the center of the circle. Good, we can see there. And PVR is a tangent to the circle at V, okay? What do we know? A tangent always meets the radius at right angles. Okay. Now also T is a point on chord SU, such that ST is equal to TU, okay? Great, a line from center to the midpoint of chord is perpendicular to the chord. Okay, that's the essence of that statement. US extended. I would rather use the word produced as a standard, because a line can be extended. For example, if I've got a line, I can still extend it like that. Does it make sense? Yikes, I don't know. Maybe I'm being illogical. Okay, let's use an extension. Sometimes when I operate, if somebody already had a wound, let's say this is the skin and then there was a wound like that. So sometimes maybe there's a foreign body, a knife blade or something. Sometimes to get rid of it, you may want to extend the wound on the edges so that you can gain access nicely, and so you can remove it. So maybe an extension is okay, I suppose. But sometimes we need to use generic terminology so that we confuse less. Because if a student thinks of an extension like this, because sometimes I do have wounds that are like this, sometimes I can extend it like so. Can you see? It's not necessarily an extension of that shape, I guess is what I'm trying to get to. Anyway, folks, whatever. I guess the suggestion is to say we're producing it. So US produced, meaning STUR, right, meets PV at R, meaning it's a straight line. Okay, so this is to suggest that RSTU as a line is a straight line. Okay. OV, OR, OS, and OT are drawn. Okay, we can see all of that. So what do we see immediately? We can see that this is a cyclic quad. Let me use my AI stuff here. This is a cyclic quad. Why do we know? It's because that angle is equal to that angle. So the exterior angle of a cyclic quad. So this is the converse, essentially. Or if one chose to show the inside angle, we can see that those angles are supplementary. Okay, that's it. And also, what do we know, folks? We know that this line is equal to that line. Those are ready. Yes, we don't know if we're going to use it or not, but once you see a question like this already, from just skimming on the questions, you know that you need a lot of things, because this one needs a lot of equalities to deal with. So you may want to highlight those to yourself, just in case you need it. Nice. So this one already proved, and guess what? It's the question. Can you see? Analyzing this was good enough. It already answers the first question at a go. All right, so let's go 7.1. We know that basically OVR is 90 degrees. Why? Tangent perpendicular to radius, right? Say also, we understand that OT, okay, let's just say OTU is 90 degrees, right? Line from center to midpoint of chord. Okay, therefore, what do we want to say? OTU is equal to OVR. Each is 90 degrees. There was no other logical way. They only connected because of their sizes. Now we can make a conclusion that indeed VOTR is a cyclic quad. Now we proved the exterior to be, so we will call this one the converse of the exterior angle of a cyclic quad. Okay, it's a converse in that if the exterior angle is equal to the opposite interior angle, conversely, those points are concyclic, meaning there's a circle around, they are on the same circumference, or there's a circle passing through those points. Nice and easy. So obviously, folks, this is much stronger, I guess. That is stronger, and the reason is the last mark. Okay, good. Now 7.2. If you look at it, it's one higher grade question, because look at that, it's ugly. Now let's study those sides, because here you would never get a clue if you don't study the sides. So this is the approach you will see when you get to grade 12. There's a lot of these kinds of questions, so you might as well learn now. OR, where is it? OR, okay? So this is this side. Right, that side looks like a hypotenuse because this is squared. It's a hypotenuse of two triangles. This triangle or this triangle. Okay, so again, we want to think about it. Which one is best to use? Do we see VR? No. Do we see OV? Yes. So it's likely that triangle. But remember, OV is equal to OS. Okay, maybe. We can see something there. But now, we will not say much about it, okay? Because I think it's giving us problems. We can see OV is part of this triangle. but at the same time is equal to OS. Now OS is a part of this triangle, it's the hypotenuse of OST. Maybe we're gonna have to think about it as well, okay? But OR is safe to say is the hypotenuse of either that or this, okay? But now OV looks like disjointed in a way because we don't see that side, but we'll see. We move on. So okay, fine, we know where this is. There's OR, and then OV, we know where it is, okay? But we're still questioning its inclusion here. Is it because we're working on this triangle, or we're working on this triangle and perhaps this one, then we're taking this one into that? Maybe. Let's look. TR is this side, TR, and then it's squared. So TR squared is already suggesting we have this triangle as well, okay? RU is this whole side, okay? TR is also a part of this triangle, okay? So we can see. So this is definitely suggesting we're dealing with this triangle, but in a way. So at times you get clues, but you're not too sure. But let's see which triangle started showing up more than once here. TR is part of this triangle, and then there's a TR still part of this triangle. So I would say OR is probably used for this triangle. Okay, again, it's just a clue. Rough work is key here in trying to uncover what is going on. So let's see. We know that OR squared is equal to OT squared plus TR squared. This is Pythagoras in triangle ORT. Okay? So that's the starting point. But now what are we going to say? Where does all of this come from? Now we don't see OT here. So it means we need to eliminate OT, right? But now OT is in which triangle? Is in this triangle. Right? In this triangle. All right, okay, all right. So we can use that triangle to eliminate OT. We'll say, but OT squared is equal to OS squared minus TS squared, right? Again, we know that this came from Pythagoras in triangle OST. Okay, can you see the systematic approach? Now this implies that OR squared is equal to, instead of OT, going to write OS squared minus TS squared plus TR squared. Can you see that? Nice and easy. So we're getting somewhere. But now what do we know? We know that OS squared here is the same as OV squared. Now it answers why OV came in. Those are ready. We will say, well, this also implies that OR squared is equal to, instead of OS, we write OV squared minus TS squared plus TR squared. Perhaps let's just try to bring in TR closer because it's already brought closer. OV squared plus TR squared minus TS squared. Now we justify this. We know that OV is equal to OS. Why they are ready. Okay, nice and easy. Now what do we see? We don't want this TS guy, but we already have the sign. The sign is already there and we have it here. Nice and easy. So what do we need? We need to now define TS squared. Where is TS squared? TS, as you can see, is nothing but half of SU, right? TS is half of SU, but we don't have any 2 there. Okay, we can leave that for now. How do we define TS? TS, again, looking at this line now, because we can see it's complicated. It's nothing but RU minus TU, right? So this is RU minus TU. So, but now what do we know about TU? Because RU is there minus TU, but TU is the same as ST, right? But now we see TR here. Where is TR coming from? Okay, let me think again. TS. Oh, yeah. Because we've got TS here. TS or ST is RU minus TU. That would be TS. Okay, wait a minute. ST is RU, which is there, minus okay, TS, first and foremost, let's substitute TS with TU because they are equal directly. Maybe it's going to work out nicely like that. So we know that OR squared is equal to OV squared plus TR squared minus, instead of TS, we're going to write TU squared. We know that ST, or let's just say TS, is equal to TU. That was given. Okay. So now we want to define TU in terms of this length. Can you see TU is nothing but RU minus TR? Yeah, makes sense now. So we can say safely, therefore, OR squared is going to be OV squared plus TR squared minus TU is basically RU minus TR all squared, and that defines TU. Nice and easy. So can you see sometimes a bit of strategy is very important here, because that's a higher grade question. Not many students solve those kinds of questions because strategy is key. Anyway, folks, how do we mark this whole thing? Well, this one is crazy. 6 marks. Maybe let's just mark everything. Mark everything because we used everything everywhere. So this being substituted is not that strange, ne? But substituting OV here, that's a mark. Oh, sorry. This is a mark for OV there. Wait, what is going on? Okay, I see. And then here, we then did what? We substituted TS for TU, okay, 4 marks. And then this entire this is a calculation, by the way. So this is a mark. So 1, 2, 3, 4, 5. Okay, so we can safely say substituting here was good enough. Suppose that was a weak mark though. 5 marks would have been fine. Anyway, folks, that's it for those 9 marks. And literally, we have finished this paper for a total of 100 marks. Okay. I hope you enjoyed the review. Of course, it took slightly longer than I wanted. But at the same time, guys, I'm not going to do tons of papers for you. So one paper, if I try to be as comprehensive as possible, this already provides a form of revision of concepts that you can go back to and try other questions of a similar nature. And that way you become bulletproof. No matter what shots are given to you, you will survive. I hope you liked the video. Spare the rants and stuff. That's just my nature. At the same time, I mean those rants, basically. But you don't have to worry about them. Remember, as a person, you need to be selective. Take what works for you, leave what doesn't work for you. There's no need to be emotional about it. This is why we need, in society, the so-called emotional intelligence, because you need to know how to react emotionally to things. You know, rubbish for you as a person, just leave it as rubbish, ignore it. But good things, you don't want to ignore those things. But you don't want to get worked up over things you cannot control. What I say is not going to change. And you cannot change it by hating it. But you can ignore it so that you don't feel bad about my situation. You just say, okay, I'm going to take what's good, leave what's bad about this dude. Because there's no point in you fighting me. But of course, when something has, should I say, a moral standing to it, then it's your duty to address it. Whether I accept your criticism or not, you just have to do it. But while doing it, you need not to be emotional by my response or reaction. My reaction may be positive, which is good, or it can be bad, which is already bad. But at the same time, is you as a society, or should I say as a member of society, you will have pointed out the carelessness in my approach. Someone who's reading your comment will read the same thing, will resonate with the same thing that you are saying. And again, you are helping to help those who could easily be misled by those who could easily be misled by my rants. So you're protecting them. So as a person, you just have to function at that level. But at the same time, being comfortable with the entire situation, because you don't have to be angry about it. Because why does it matter anyway? Anyway, folks, I will talk until the Lord himself descends and strangles me. If not, I'm not scared of the devil, unfortunately. So that's the guy I would fight until I no longer have any strength in me. And I'm not scared of that dude. Whatever he throws at me, I deal with it nicely. The Lord is the only person I would never fight, because he's the author of my existence. I never chose to be here. He put me here. He even directed some of my paths. Yes, I made decisions, but I would like to believe that those were things he actually made me for, because I would never decide against his will, even if I liked. So the Lord is supreme law. I can never even escape him willingly. You get it? Take the parable of Jonah. Guy is sent to Nineveh, and then he rushes to Tarshish because he thinks that's the safe place. And guess what? The thing swallowed him and went and spewed him right where he was supposed to be. This is just to show you that even if you run away from your destiny, the Lord will find a way of driving you back into your destiny, whether you like it or not. That's if your destiny has something significant in his kingdom. If not, then whatever choices you make, because God gave us free will, we make our own decisions about how we want to live our lives. But at the same time, we should be ready then to face the consequences of our choices and actions. And God is not going to care about that. I see a lot of so-called righteous people going around trying to correct the wrongs in others. The reality is, those people are choosing to live that way. And they will bear the consequences of that choice. But again, there's no one at fault in there. Because when that has nothing to do with God's will, God is not going to care about that. He's going to let it be. And you're going to suffer if it ends up making you suffer. And you're going to win if it makes you win. Because that's just something that is not against His will, especially in alignment with your existence. This is why rich people don't actually suffer as many would think they would suffer. Because those religious folks, they go around saying, rich people, wrong, they're going to burn in hell. No, you're lying to yourself. Actually, that's just you being bitter. Why don't you actually try for richness as well? Because no one stopped you from becoming rich. You actually stopped yourself by not doing enough work that you're supposed to do so that you can become rich tomorrow. Like not doing your work properly as I'm showing you. Then you're not going to be rich. You're going to be poor. You're going to work for someone else. And you're not going to make it. Because if you're earning a salary from somebody else, chances are it's not going to be enough to make you rich. But it can make you survive. Okay? That's okay. Some people are okay with that. And in fact, it's a most peaceful way of living because you never have to worry about running a business and making it thrive. If you want to be rich, it comes with responsibility. To keep those riches, you're going to work hard. You're not going to sleep when others sleep. You're going to get involved in making some dodgy deals sometimes to keep your business afloat. If not, it goes away. Okay? Unfortunately, certain things come with certain uncomfortable, realities about them that you have to deal with, unfortunately. But you can't just be rich and relaxed. There's no one who is rich who is relaxed. Believe me. Only thieves are like that. But even they have to worry about being discovered or being ratted out by one of their members or whatever circumstance would lead to them being discovered. So all I'm trying to say, there's no riches without responsibility and serious responsibilities. You're not going to be rich and not do anything. Don't hear people who are doing these stock markets and stuff when they want to recruit you. They'll tell you, no, you have to make your money work for you while you sleep. Rupert is still going to the USA to defend his position so that his businesses can thrive on both sides of the world. Because being rich means responsibility. Remember, for you to be as rich as those dudes, it means you are a part of a corporation. So you don't only live for your riches, you live for other people's riches, unfortunately. Because the moment you start to isolate yourself, then you will fall from that level of riches, isn't it? So can you see those people are still busy defending the nation and everything that they stand for? Because they're not going to just be sitting on a boat somewhere, sipping martini and whatever, watching some bikini babes on the beach and what. No. Those people are hard at work. They're monitoring systems. And yet they are rich. Yes, they get to drive a nice car easily. They get to live in a mansion easily. But there's so much heavy responsibilities you as a common individual, you would not go for. Because guess what? You are too lazy. Because all you think being rich is what you see in the movies. Being on a yacht somewhere, just not doing anything meaningful. That is not the true sense of being rich. That's a lie. Is it an illusion? Is it? Something like that. It's rubbish. It's garbage. And many of you live a fantasy. And a fantasy is rubbish. It's not true. Doesn't work out. Never comes true, by the way. Only a vision comes true. Because a vision will cause you to do things about it. And you will later get it. Hence we call it a dream. But a dream is something else, actually. It's not what we say. But what people have is a vision. But we call it a dream, which I don't understand why. Because a dream is just an instantaneous occurrence that doesn't make sense. Imagine in a dream, you dream being a pilot, and yet you wake up, you're not a pilot. You dream being rich and you're not rich. You're being killed and you're not dead. You understand? A dream is really stuff that doesn't make sense. And of course, it makes sense why it happens the way it does. Most of the time when you're dreaming, your brain is functioning below optimal levels. So there's lots of erratic issues there because systems are just, sparking, neurons are just discharging electrical stimuli in a disorderly fashion, because in a dream there's usually no order as well. Very few people have dreams that have an order, where you can see that you yourself are actually reasoning the way you would normally reason awake. Then it usually tells you your brain is really a superpower, because we're not all the same, unfortunately. But normally dreams, which is what happens when you sleep, are mostly rubbish. Some are good, because remember the depth of your sleep as well says something. Some come when you are not that deep in sleep, and that means your brain is near optimal functioning levels, and that would mean those dreams would have to be more informed than the rubbish that happens when you're in deep sleep, where you're not even thinking rationally in that dream. So, no, let's forget about it. Don't chase your dreams. Chase your vision of yourself, because that is what works. That's what can come true. Dreams, not necessarily. Unless we are not talking about the same thing. Okay? Do you see how so many things we take for granted and carelessly so absorb? Because everyone, chase your dreams. What is a dream? Do you know what you're talking about? So we are using a word to imply something else. Did you even dream becoming a doctor? Do you see yourself as a doctor when you want to become one? Not necessarily. You dream about things that are probably not even related to what you want to become. And I don't remember dreaming myself as a doctor, ever. But I saw myself as a doctor, and I am a doctor because I did something about it. Anyway, guys, goodbye. I'll see you when Jesus allows me to see you again. Keep pushing, revise your notes, study, and practice. Make sure everything is all together working well, in unison, or as a unity, or as a unit, not unity. Okay, unify all the ideas, you will see, you will thrive. But if everything is disjointed, you might survive, but with difficulty, and you may not survive again after that. So you want to ensure that you thrive each time. And this is when everything is working together nicely. And this doesn't come from, just careless. Remember studying, guys. Let me tell you something about studying grade 11s. Because a lot of people are going to tell you things that don't work, and you would believe that they work. First of all, when you study, ensure that you realize something. Because studying is basically what we call a careful analysis of something. So when you say study this, it means carefully look and realize some hidden truths. Okay? You're realizing some hidden truths about something. Then from here, once you realize all these things, and from a careful analysis comes knowledge. But knowledge is not that deep. You just know, okay? If this is this, it is that. But from here, if you keep studying your knowledge as well, right? Because once you start to doing that, you're going to develop a way of taking notes. Now, notes is not reproducing what is written and knowing it, and you call it notes. That's nonsense. That's not notes. You also note further details. Further, perhaps small details, because notes are usually not big things. Details. Usually very small details. Those are notes, because you start to say, okay, I know this, but technically, knowing it, this is when it applies, this is when it doesn't apply. This is how I use it, this is how I don't use it. You get it? Those are notes. Then from here comes insight. Now that is deep knowledge. It's what I would call working knowledge. Although the word would be misleading, working knowledge, because insight is the ultimate. When you have insight into things, insight, it means now you can twist and turn with your knowledge. You will solve as many issues as you can. But if you don't have insight, trust me, you'll always need somebody to give you the notes first, then to enlighten you. Right. Because this can only make us notice you, but not really see you as outstanding. But once you have insight, you will definitely be the outstanding in a group of people. And try for this if you want to be an influential individual and useful individual. Perhaps maybe more useful, let me just put it that way, if you want to become more useful, because this can make you just useful, because this guy with insight will impart knowledge to you so that you can be user-friendly for him, but you will be his slave. But when you have insight, you actually carve your own path. Even when people plot against you, they fail miserably because you keep transforming. Okay? So, I don't know if at all we should say study then. But study is so that you can end up here with insight. You just read for knowledge. And reading is not studying, technically speaking. It's just a way of being familiar with things. And familiarity is not knowledge of anything, because you are not so sure of what you know and see. But yeah, it usually is, but is it always so? You cannot answer that question. That you get from reading. Okay, it appears to be. But is it always like that? You see, from reading you only see what seems to be and what appears to be. But once you know it is so. You will even understand how it looks different in different setups. Then with insight, you can use it at any given point, given the opportunity. You get it? Yeah. So know things, people. Don't be superficial and too common. You are a special individual. God didn't make a mistake by adding you into this world. But don't make him regret. All right. Okay, guys. I'll see you some other time. Goodbye.